LLMs can make the introduction of information. There's even ways you can introduce an LLM into the code with this and do some even more expansion of that. This lab has the opportunity to do some really cool stuff, and you do some great things with it. The lab itself has opportunities to work specifically in the console or within a GUI environment as well. So you can see how we can make that happen. Let's go ahead and take a look at that really quick. So we'll do Magpie Runner and run this. And here we have our Magpie Runner. Hello, let's talk. And if I type in clip, because we know that we're talking about that, it's like, oh, you're Mrs. Klipscott. Do you know Abby? And then we do clip again. And do you know Marvin? The different people who are inside that first option right there. So we have a random response. It's like, I want, oh, I would like a spicy burrito too. So they're using that string processing so we can have that happen. I don't like, you said, I just like bland food. What don't you like about it? Oh my gosh, we can see exactly how we're making that happen. And so we can use that ability right here so we can have some interaction with this. And again, I'm just using the terminal window for this. This will be happening inside a console window on the application. So we can actually practice how we can work with this and have things happen inside the project. So if I just type in the phrase, have a hamburger, oh, that sounds yummy, tell me more. And so we have the original response right here. So if there is a hamburger, if it's greater than 0, that's in that spot right there. So we can actually have that happen. We can also talk about the importance of how the structure of those selection statements happen, because it'll first do this, then this, then this. And so you have to make sure we have a proper direction of selection statements. This is a great way to introduce how to do complex projects. And so with that, you can see that there is a bunch more that can go beyond that. So it has the labs have more than simply just that quick thing of the receipt, but you can have a whole bunch with that. You can actually do quite a bit with it. So that was again, I have to introduce all these videos, and rather than the remaking and redoing all the work, I'm going to be lazy and do the work that I've already done. So with that, and that's one of those tricks again that I recommend using with your students. Like if you've got something you've made once, it's okay to use that video in class when you're with them, because like, hey, I can actually go through this. It's like, hey, I've done that one little part. It is totally okay to use those tools with that. Now, when I'm developing to the students, I do that live with them because I want them to actually see that process, even if I've done it before, but I may not complete entire projects with them and doing live code with them, because again, that's their responsibility. That's where they're learning how to do the completion part. I'll get it started and get to a part with that, and I'll go from there. And so with that, we are going to do something new. We're going to do file IO with a string. Who has done file IO before? Okay, a couple hands. Who has not done file IO before? Okay, also a couple hands. So now that file IO is part of it, we have to learn how to work with this. Now, when working with file IO, there's a couple different things you can handle. You can have where you can handle exceptions, or you can pass it down the line. You'll see examples of both types of dealing with that problem, with the exception that has to happen with file IO inside the code. I work with the I'm going to deal with it. You can just put throws IO exception on your method header and then not deal with it. I don't encourage this. Mostly say that's a bad plan. I have a participant wanting to show up. Yes, we'll put Alexa in, boom. I purposely handle exceptions in my code, and I talk about how to do that because I think it's more critical to actually show that. Even if it's not a big handling of it, it's the idea that you understand that what's going on behind the scenes at least a bit and address it. There's ways you can do that. In this case, where it just does simply an output statement, that's at least enough it can say what's happening so people understand what's going on. I mean, people, I say in this case, it's your mammals, the students that we're working with. But that is what one of the things to make that happen, and so we can work with that. So we're going to do another project this time. It's going to be in Eclipse as we'll all be working. You can work with this project in BlueJ. It works just fine in BlueJ. It works just fine in Dr. Java. It works just fine in any IDE of your choice. You can also do this even in CodingBat, or not CodingBat, CodeHS online. We will be working with a file. If you're working with files, of course, there are a couple steps on the BlueJ side. Just your file that we're working with is just going to go in that same either Finder or Explorer directory that you're working with. I'm going to create mine just straight in Eclipse to make it easy, but you can do it just about anywhere. So just using plain Notepad or whatever. So we're going to look at how we can actually read a file and read to a string, because that's the first process of doing that. It's like, oh, I want to actually read a string as a file. And so we're going to work with the first process of that so we can use that, and we'll be building it when we work with our array lists and our CSVs and our other stuff tomorrow in class and on Friday as well. So we can have some more buildup of information, because that's, learning. I know, weird. So coding that can get out of the way. Okay, the AM video from this morning has been processed. Okay, so that's posted as well. The afternoon video will go process when we get up at the end of the day today. I just have to leave that open. Code HS, leave that. Parking lot, nothing there. Ah, yes. Okay. Mentioning change up the order for College Board units. Do I find any big issue with this? Not so much. So that's a great question from the parking lot. Like I said, it's that idea of the spiraling out. So it comes back to the things and it's like, oh, here's where this comes into play. I have students look at where stuff is inside the AP classroom stuff, and I have them, oh, here's that stuff that it's unit one. It's like, it says unit one, we're in Q3. I don't care. This is a review of that concept. And it's like, because it's like, and I explain that, making sure the students know that the unit number is not the units for class. It is what College Board says. We have, the units and modules we have in Canvas. That's our class stuff. It just happens to have that structure over there. And so I do have a couple of students like, why is it we're going over to this? Because we're teaching things the way I work with it. And it's like, oh, okay. And it's like, it'll make sense as we go along. It's like, if you have questions, ask. I'm totally okay with that. But yeah, good question. Thank you. I appreciate you putting it in the parking lot too. That's a perfect one for me to check too. Um, all right, so the next thing we have on here is talking about control structures and working with file IO string. Unit 3, I'm going to come back to this in a second. We're going to do our file IO string first, then we'll go into Unit 3 with class design and monsters. So I'm going a little bit out of order, but again, I think this is a good thing to come back to and work with, especially with how we are. So I'm going to go over here to Eclipse. I'm going to close out this workspace. So we'll restart Eclipse. Nope. Save. There we are. And I'm going to make a new workspace just for this. And so I'm going to just call this Augsburg. And so I'm working with the Augsburg. I have a workspace for everything. So I have, as you can see, I've got my Dev 2024 Java. I've got my, oh, I hit St. Brain and I went to go hover. Didn't mean to do that. File, switch workspace. Other. I didn't mean to click on the hyperlink. I apologize. There we go. And I'll launch the workspace for that so we can actually work with this current new workspace. Um, I have the welcome screen, I just have students close that. I also have them close out the task list and outline windows. We'll never use those. They're not very helpful. And when I'm working with them to make things, nice, I can just go ahead, I can go to the window tab and I go over here to the perspective and then save perspective as. And this is now just the Java perspective. So do I want to resize this? Yes, or reuse this? Yeah, because this is how I want it to automatically be set up, is using that perspective. Settings for Eclipse. A couple things that I always work with, and I start this before we write code just to make sure that things are set up basically. Settings are accessed if you're on a Linux or a Mac box, it's under Eclipse and then settings, command comma. If you're on a Windows box, it's under Window and Preferences, but it's the same thing. So you go to the settings right there, and under the Java, and then code style and formatter. I'm going to make a formatter for this. I'm going to make a new one, and I'm going to call it just Cody. And on the brace positions, all these I have as next line, except for the last two. So I have vertical alignment of squiggles, with the exception of array initialization sequences and lambda bodies. Those are special cases that I get to in my class, but because they're special, I don't want them looking like everything else. So array initializer and lambda bodies are on the same line, but everything else is on a vertical line. So it's very easy to see vertically. And so I just hit apply on that. And then over on blank lines and in control structure, or new lines, sorry, not blank lines, new lines. And then on control structures, I put a checkbox on the first three. So again, it has them so that they're all separated out like this. So if else, right there. And we don't have catch and finally, but if in this case, yeah, but we'll have them in a minute. So apply that and okie dokie, apply and close. So that's the settings that I automatically start off with my class. So aligning the braces and having the new lines on the else, catch, and finally. So those are also vertically aligned. So for the keywords themselves. We're gonna make a quick project Making a project is just really easy. Click the Make a Project link, or File, New, Java Project, or right-click New Java Project, all of which work the same way. Naming projects, I have my project names have no spaces, so they can easily go into our source control. And so this is going to be demo file IO because it describes what the project's about. And you want to make sure you uncheck module-info.java. If you're working with a recent installation of Java that has either module or package info that could be possibly created, those are for large scale development, way beyond what a classroom assignment would be. We don't need that. So just uncheck it and you don't have to deal with it. If you accidentally leave it checked, you just delete the file, it's gone, everyone's happy. So no big deal if you have one, just delete it. Okay, so I've created my project. There's my demo file IO. You can see I have my source folder. I do talk about how the naming convention on this came to be. It's like, oh, hey, we have limitations on how many variables we can have and what we can do for file names and folder names and all that fun stuff. So the first thing we're going to do is we're going to strip the vowels out. And if we have to, we'll add other letters to tell things. So source is source because that's enough. Since Java's been around, we haven't had that restriction. We can have variables and folders with more than 3 letters. But Java was, hey, C++ did this, so we will too. So we've got a source folder. That's where everything lives. Inside the source folder, the first thing we do is make a new class. And I'm going to make my controller first. And so there's my controller. Let's make my font a lot bigger so y'all can see it. Is that legible for y'all? Okay, fantastic. In class, I make my font ridiculously big by default. So that you can see it on the monitors that I'm projecting to, the screen that I'm projecting to, and when my screen is shared via the LAN school screen sharing tool that we have in class, they can have it so they can read my code at everything. So it's like I want my code to be as easy to read as possible. And I like the fact that it has color because that's very visually interesting, and the students get to see what patterns happen with that as they go through. Like, oh, code looks like this. And so that's one of those things I find that have been very helpful is using the visual color of code so students recognize the patterns that happen when they type in certain words, etc. Okay, so we are going to be working with our constructor, our controller first. And again, I talk about how that we split the code into piles based on what we want to do. Now in my class, I use an MVC architecture. If you watch my videos, it's like, oh, here's this package, this package, this package. I'm not doing packages with y'all. I will make that concession when I'm working with teachers that I won't do packages. I won't put code in main. I just can't. I can't make that concession. That's just not me. But what I will do is I'll keep it so it's all in the same default package. Eclipse will warn you about not putting it in the default package. That's okay. That's just a warning. It doesn't hurt anything at all. But we're going to make this so we can read from a file. So we're going to start by doing some basic stuff first. I start having students make objects very early, like I said. And so we talk about what some of those pieces are. We don't have to go into all the detail. We'll hit a little bit more on that here later today. But the first thing we have is our controller. I'm going to make a constructor to start off with. So it's a public controller object. And a constructor, again, has the same name as the class, as the file, as the class name. And so all 3 of those are the same. You'll notice right here in the top left of the file, it has that little asterisk. That's a good cue for you that you haven't saved. And Eclipse tries to compile as you type along. But if something's not right, hit save first, and that might actually solve your error. Because it's like, oh, if you haven't saved recently, that's a great thing to do. And I always do the save all, Command Shift S or Control Shift F if you're on a Windows box, or click the 3 floppy disk icon to save all the active files. That way it's like, oh, I'm saving everything. Again, I like that process of always having stable code as I go through. And so a constructor has the public keyword and the name of the class, nothing in between it. There is no void here. Biggest mistake I wish that Java did as a language is if they restricted, if they could make it so you can't name a method the same as the class. I would love that because kids often put void right here and they wonder why their code gives them null pointer exceptions. Because like, oh, why don't I have void? Because you didn't write your constructor. Oh, but I do. I'm like, no, you have a void right there. Oh, and they have to fix that all the time. But so make sure there's no void there. And then that same method, start. So public void start. And I save that right there. And this is how my controller or my class that's in charge of running code always starts. And so I have the kids like, here, we're going to make this first. This can't do anything. It doesn't have a main, so it can't do anything. But what class do we use that has a main? We did it in BlueJ.
Runner.
Runner, yes. So let's make our runner as well. And our runner has that same line of code all the time. So I can either just go right here on the source, right click a new class, or file new class, etc. It should say, oh, it's inside the source folder. Great. The name of this is going to be runner. I never use the checkbox for this with students. I don't even talk about it with students. I hope they don't read it and notice it. They're not as obsessed with text as I am. And if they ask, why don't you do that? Because I want you to practice writing code. And it's like, if you use that, delete your file, remake it again. I will tell them to do that. It's like, no, just delete it and remake it. You need to practice. If I can do practice for this and I've been doing this for N years, you can do practice with this because you've been doing it for a month or a year or whatever you've been doing it. And so right there we do that. And again, in the writing of code is good practice because again, we're building that muscle memory. We want them to always think the pieces, not simply just assume what's going on. And so in our runner, it always has that method. PSVM is the abbreviation. What does PSVM stand for?
Public static void main.
Public static void main. And I don't explain any of these words when I first start working with this. And I definitely don't explain what those square brackets are. This is just magic you type that you have to start off with. I always hit save repeatedly. I want students hitting save on their own, getting to that process that is saving is a thing they should do often. And because I use GitHub as a source control, they also have to do commits with that, where they have to reflect on their code, what they've done on a regular basis. Um, I'll talk about that. There's a lecture inside the channel about that, but that's something, it's not the inside the subset, but I think it's a really good practice, especially as you get more practice writing code yourselves. But we'll talk about that later. Okay, so I have the same two lines that always go in all mains all the time. I make the name of the controller, the class. I give it a name of a variable, and I do boring. I just do app. Then I call its constructor with the keyword new. That's a controller object. It has no parameters. And I say, what method did we just make as well on the other file? If I click over here in that triangle, I can see it right there. Oh, it's the start method. Oh yeah, start. And so I say, hey app, call your start method. And now I have a fully functional program that does nothing. If I go to my window and show view and pick my console up, there's my console. My program terminated successfully. It did nothing. Woohoo! I have successful code that does absolutely nothing. Because again, I want to be at a space where I have code that functions, even if it does absolutely nothing. My code is completely functional every step of the way through. It's like, okay, make sure you understand how those pieces work. We go to the controller class. We're going to go over here. We're in the controller. We call it constructor. There's no code in here, so I don't do anything. So I come back to the runner. I go to the start method. I go in the start method. Oh, there's no code in here, so I do that. I come back to here. I go to the runner, and I'm done. Oh, visualize what's happened inside that code. I just stepped through that whole process. And so that's what happens as we go through it. And I'll have the students do that multiple times throughout the year. Like, oh, I go here, then here, then here, then here. I come back because as soon as I finish that constructor call right here, I'd come back to this file. And then I'd come back to the controller again, go into the start method, then come back, etc. So it's seen that there's a pattern that the code is jumping around. It's not just staying in one thing. So I can see where the code lives, how it operates, and where it executes. Okay, my runner is done. I never have to make any changes to it again, so I can just close it and get it out of the way. It's not critical. Now, what I want to do is I want to make it so I can read text in from a file and put it on my screen. And so we're going to write some code to make that happen. Now, the job of reading text is not something that belongs to my controller. My controller's job is to tell things what to do. And so I put my file handling in its own class because it's like, oh, this belongs to someone else. So I'm going to put that, since that code has the job of that code is not part of just running the project, I'm going to put that code in a different file. And so we talk about the idea of decomposition and roles and responsibilities of code and how we want to split those roles out as we go through. Hang on one sec. Don't have the AC on, so I'm gonna have the fan on so it doesn't get too hot in here. Um, but we want to have the idea. I saw that I didn't have my fan on. It's like I'm fine, but I know my wife will be saying it's too hot, so I have to make sure when she gets home it's not going to be bad. Um, sorry, but we have to actually build those pieces up. So what we're going to do is we're going to make a whole other file to do that job because that's a completely separate role, and we try and put the code in the files that where that job belongs to. So I'm going to make a file called IO controller because it's responsible for input and output. And so it's the IO controller because IO, input, output, and controller, that's the job that has that's what it's in control of. The controller is just this broad perspective thing. It's just in charge of stuff. The IO controller is just in charge of IO. So I'm gonna make another new class right here. And well, actually, before we do that, we'll just do a system.out.println. System.out.println and semicolon. We are going to read from a file. And we'll make this a little bit smaller right here. Okay. Is that still legible for everybody? Okay. You can change the font and stuff on this to make it a little bit bigger. I have done that before. That's on that same settings page, but you have to go a little bit deeper to make those changes happen. But you can make this font go a lot bigger. That's time that I just didn't want to spend with you because that's something that you can do, but it's not critical for that. And you can just by seeing this structure right here, even if it's small text, you can see these structural components and work with that. But that's something if you want to in your classroom, you can make that bigger as well. And I've done that, but for purposes of this meeting, yeah, we're cutting some time out of that. That's something I have class time for, not we don't want to waste the time for this. Okay, so we're going to read from a file. So I have that just a quick little thing. If I hit play again on this, my project runs. Oh, I'm going to read from a file. It's right there. It tells us what we're going to do exactly. So we know what we're going to do in our project. So we're going to make a new file called an IO controller. So I'm going to go over here in my package, right click new, and it's a class. And again, the creative name of IO controller. And I use the Pascal case naming convention for that when we're working with this. Now, um, here's a public class. It's totally available. When we're talking about IO is something that we mentioned earlier with Scanner. We've got some rules and stuff we want to do when we're talking to resources that are beyond our regular scope of stuff. And so we have to make sure that we keep that in mind that, oh, we're going to be working with some stuff. To do IO, we also have to definitely add imports. And so I think it's very useful to add this in early, like in Unit 2, because you can read stuff in from a file and there's not a lot of extra work that you have to do, but you can have and use methods. And because I'm using lots of objects, you could put this all in main other than the IO controller. That would have to be in at least its own method on that. But this, if you really, really wanted to, this could all happen in one file. I find it helpful to put smaller piles rather than one giant pile because you can also reuse that code and extend that code and integrate that from other projects, I think a lot easier. Soapbox off. Okay. So IO controller, the first thing we have to do is we have to do some imports. We have to tell Java how to see some things. And so imports go at the top of the file before the class header, because that's information that when it gets compiled, it needs to know before it actually goes in that compilation process. And so we have import java.util.scanner. We have import java.io.file and import java.io.io exception. So those three things we need to have in order to make this work. You notice right now that Eclipse is giving us a little yellow underline of uselessness. It is a warning, not an error. There's no bad things. It's just, hey, I haven't used anything with this. Are you sure you want to have that there? There is no negative penalty for imports in Java. If you import code in Java that you don't use, woohoo, no negative cost attached to it. But the Eclipse will warn you if you haven't used those pieces. So we have three imports we're going to start off with our IO exception, our file and our scanner. We've already used scanner when we're talking about keyboard input. That's not the only way to use scanner. Scanner can be work with a file as well. Scanner can even operate on a string. And we'll talk about that possibly another time or just watch my video on using scanner with strings. The file type is how we recognize a file in Java. I know. Pretty easy stuff. It explains exactly what it is just by the word. And then an IO exception is the error type that we have to deal with when we're working with files. And so we're going to have that handle. Now, when I write my IO controller, I use a different paradigm or structure than writing a regular object-oriented code because the code needs to live in a class. But I don't need to make an instance of IO controller. I just need the IO controller to be in charge of these methods. And so I will use static methods for all of my things like that because it's a utility. It's not object oriented in the actual structure. It's just, hey, go do that thing. And Java says that go do that thing has to live in a box somewhere. And that box in this case is IO controller. We have the math box for all the math methods. You can't make a math object. You can't instantiate it. It doesn't have a publicly available constructor at all. But you can say, hey, I want the square root of something. I want to know the exponentiation value of something. I want to get the unit of use precision, the min, the max, etc. of something. But you can't make a math object do that. You just say, hey, math, go do that stuff. And that's what we're going to do here. We're going to make an IO controller that can go do that stuff for us. These are utility methods. And so I put all utility methods with a keyword static attached to it. And so we're going to make a public string, static string method. So public so everybody can see it. Static so it's not called in an object-oriented way. It's just called as utility method. It is a string return type because we're going to return a string from the file. And I'm going to give the really creative method name read string from file. I know, creative names. And in order to do that, excuse me, I need a parameter of a string that is the path to that file. And now I have a red underline of the red underline of doom exists because I'm missing something. The header tells me what I'm missing. How many people,
Return,
what's that?
return statement.
A return statement. Yes, I have a return statement missing because this is a string method and it needs to have a string that comes back to it. And so I use that process of having a stub. So I always have a valid piece of code. So the first thing you do is I don't have a magic, just return some empty string or null. I have a string content. Nice name for what I'm putting, right? I'm going to assign it the default value of an empty string. Excuse me, make sure my equal signs get there. And then I'm going to return that variable, content. And so I always have a variable. This is going back to what Torrin was talking about. I use variables to trace through this rather than simply just returning the content of something or returning a method call, because I want to have not just some magic value, but something I can step through and trace logically, either on my brain, in my brain, or using the actual step through trace of the debugger tool. So they can see, oh, here's what's inside that value. I can watch what happens to things. And so I can see change inside my logic and code. So now I have a static method. I have a variable that's defined, initialized, and returned. So it compiles. It doesn't work right, but it's stable. Okay, so I have all the stuff that I have to have for this. Now, we're going to now read the string from a file. So we need to first be able to make it so we can get a file from that path. If you're using a static method, everything you need has to come in as a parameter because there is no identity to it. It doesn't have any sense of self. There is no stuff to it. It's just, here's all the stuff you need. Go and do stuff with it. Static methods get everything they need as a parameter or created inside themselves. There's nothing that they don't know anything external. They're just given the stuff they're sent as parameters. And so I'm going to build a string from the contents of that file, but I have to be able to load that. And so here's where some code happens. So we're going to use what's called a try with resources block and a while loop to make that happen. So I'm going to do try parens and a set of squigs. And inside that try, I'm going to make a scanner from the contents of that. So make a scanner. I'm going to be creative with this, call it file scanner. And it's going to be initialized as a new scanner from a parameter that's a new file from the path specified. And I get a red line right here because this may not work. This code could break. It's good code, but it can break. So I have to put a catch block on this. So I have to catch the IO exception. And I'm going to be really creative here, named error, that could happen because of that. And so let's shrink my font one step down so you can see that the whole code right there. So this is the structure for the IO. We haven't done anything yet, but these are the pieces we have. So I use what's called a try with resources block. I use the try with resources block because it automatically closes the scanner for me. That's Java has the will automatically say, hey, when you're done with the code, when you're done with this file, close it and move on. I don't have to write the file scanner.close line because it's already done. And this is a good coding practice. This is a good way to work with this. Simply writing throws IO exception on that method header, it'll make it compile, but it's really not good. I want my kids to have at least the beginning of good coding practice. Even if they're not professional software developers, they know why we're doing this. And so the first thing we're doing right here is, hey, I'm going to try and read a file. And if it doesn't work, I'm going to catch that exception and I'm going to tell the user, hey, there was a problem. System.out.println. There was an error. And do a sad face. And then error.print stack trace. I'll tell the error to print its information about. The program won't crash, but it will say, hey, here's what the problem was. And so my code will say there is an error. It'll display the error information to the screen, but it doesn't crash. It's like, hey, here's what the problem was. Cool. Keep going. Keep on working. And I think this is a better practice so they can see, oh, here's what happened. Here's what the error is, and they can go fix it later on rather than their system crashing and having to like, oh, I have to fix it. It broke, but I know here's why it broke and I can go back and fix it versus it broke, why did it break? And have that negative, it's crash, what's going on? It tells them it didn't work, but it doesn't shut them down. Okay, I think it's a good way to practice that. Does that make sense? Now, right now, it's not doing anything with the file. It simply just said, can I see it? Okay. And with a file, we don't know how long is in the file. What Simon Says game is best if we don't know how long to do something? Clap your hands 3 times, or everyone in the row clap your hands. Which control structure do I want to use because I don't know when it stops?
While loop?
A while loop. So in my try block, I have to put a while loop. So while my file scanner dot has next. So as long as my scanner has something to read, I want to keep doing this. Now I'm going to say, hey, content plus equals file scanner dot next. So as long as there's something in there, grab it. And when you're done, you leave the while loop. Nothing doing the try block. Didn't throw any errors. So I'm going to give back what I got from there. So that whole code right here for the method, make sure you can see that. Can everybody read the entirety of read string from file? So we're going to say, hey, let's make a string. We're going to see if we can open that file and send it to a scanner. As long as that scanner has stuff to do, read through it, put it into this box, and when you're done, give the box back. If when you're reading the file and it breaks, say, here's the error message. Don't break, and here's what you got back. So that's what we have right here in that block of code in read string from file. Questions about the algorithm of file reading?
So I'm assuming that there are, because I haven't really gotten to the weeds of this just yet, limits to the amount of data that that content variable can hold.
Function,
right?
no.
No.
A string is arbitrarily large. You could
So if I had a publicly available copy of War and Peace and I
totally,
read it and it would read the entire thing.
you could put all of War and Peace in one string. You could put 5 copies of War and Peace and put in a string.
Hmm.
You could sort War and Peace, put it in a string, and then put another copy too. Totally fine. You want to do a Wikipedia dump? Yeah, you can do that too. String is functionally not limited. It can hold arbitrary amounts of text, ridiculously huge. So yeah,
Could I ask a question?
yes, always.
I don't know if it's a silly question, but why didn't we need a constructor for our class iController?
The IO controller, because it's not creating an instance of itself, it is just going to be used as a utility tool, a structure. We have that static method. We won't even, it's just a box to hold utility methods. And when we call it, we can't call a constructor on this because there's nothing that it can be constructed. We will just say, hey, IO controller, use your read string from file method.
Oh, so it's gonna work like just like the math class, sort of. Oh, okay.
Exactamundo, yes. Yeah, utility methods I don't put them in a class with a constructor. I just put all the utility methods in a appropriately named utility file. In this case, IO controller. I've done utilities.java too. Because like this is a method that need to exist, but they don't belong to anyone. We just need a box to hold them. Yeah, great question. Okay. Now this is not finished, but it's our first draft because again, we want to have the idea that we can test this out and make it work. And so we're going to see how this works. In my project, I can just make a new text file and it should go at the project level, not the source folder, but at the project level. And so if you're working with BlueJ, just go to your Finder or your Explorer window and put a text file in there. Okay. And so just Notepad, it's great, or save with Notepad to that directory. I'm just using Eclipse because it's right here. New text file. And here are some words, many on different lines. Keyboard mash. Save. I'm going to put inside demo file, and I'm going to call this the critically named sort demo.txt. The extension honestly doesn't matter, but .txt tells you and your computer that it's a text file. So giving it .txt makes sense. And I'm going to say okie dokie. And you can see, if I look at this, if I close my source folder, you can see that demo.txt is not inside that folder. And it's right here. If I close it and reopen it, boom, there's that file again. So I've got a file right now that has a bunch of stuff in it, clearly text, nothing special, just words. Alexa, you reminded me to drink. Thank you. So now that I've got that text file, I'm going to go to my controller and I'm going to reference that data. And so I'm going to use my controller. I'm going to say, hey, I want in start method, I want you to grab that information. So I'm going to make a little private helper method, private void demo read file. And after this, I'm going to call demo read file. So I have a stub of a method that doesn't do anything. I call that method after I grab the input, or I print the output out. I'm going to say that my string data equals, and then IO controller dot read string from file. And I'm going to pass it the name of that file, in this case, demo.txt. And if I just pass demo to it, not demo.txt, right? And then we'll do system.out.println demo. So I'm going to print that data out just to the console. So if I just pass it demo, not demo.txt, not the correct file name. So no code errors, it compiles just fine. But when I hit play, ack, my program terminated. There was an error, and then it printed the stack trace, file not found exception, demo, no such file or directory. So it told us what the error was. It didn't crash our program, but it did print the error stack that was attached to that. So my program terminated normally. This error that's printed out isn't a bad thing. It's just saying, hey, this is what the print stack trace calls, but it didn't shut my program down on its own. So if I change the to demo.txt and I rerun that same process, here in words on many different lines, wait, there are no lines. Ack! Oops! Remember we talked about how next just reads the next word? It ignores all white space. So next is usually not the best choice. So in my scanner right here, rather than simply just reading one word at a time, what is really a better process? I'm going to use, instead of that, I'm going to use next line, which will read one line at a time. And then I'm going to say, hey, content plus equals. And I'm going to append a new line, the \n, the saying, hey, you read a line that goes up to but not including the enter key press. It eats the enter key press and then returns. And so I still want to maintain those lines of text in that string. So I'm gonna, as long as there's this, as long as there's next, I'm gonna read the line, store it in there with that new line on there, so it puts a line with it as well, and save that small change. Go back to my controller, hit play again, and hey, that content looks an awful lot like that content. It matches now. And so with this, let me shrink this down right here, get this out of the way, florp, and we'll minimize that down. So you can see everything we did with our IO controller to read a string from a file. This is code you can easily use in your classroom, and you can teach early on.
I have a question. This is, yeah, of course, this is like the cleanest way to do that. But is it also possible to put like a /n in the file? Like if you wanted in between, like somewhere in the middle of some line or something like that. Is that possible
So the
to read it?
\n, so you could read like every other word you could put a new line. So if I wanted that, if I did that with has next, and then I did dot next right here, and then a new line like this. So I run that same version now. Play. And so that will put, here's each word on its own line as it read it. And so, yeah, you can totally build separate things from that.
No, but I meant, what if the /ns, or is it possible to have the /ns in the text file? And
Uh,
would it recognize that?
so if I put like the \n inside right here, so they do,
Yeah, yeah. Would it recognize
I'll do
that?
two \ns right there between 2 and 2342. So if I grab that right there and I read it as a string, so between 2 and 2342, it just treats that as a string. The \n
Okay.
sequence is for that's actually /n. That should be \n. Yeah, that's \n. But it's the backslash is like, hey, here's when I'm reading the invisible characters that are in that. So that's the stuff that tells you that's a new line indicator. And so the enter key press is that \n versus that \n is just the character backslash and then an n.
Okay, so there's no way for it to register some kind of carriage return on the text file or any kind of
Well, so
element.
when you're doing your IO controller like this on that, so dot next, if that like whatever it reads, if the content of that, so if content, you could do if parens content dot equals parens quotes \n.
Ah, okay,
Do logic,
got it.
or you could do backs and then carriage return, or if \t or any other escape sequences, you can do stuff. But that would be, you'd have to run those tests with that as it reads the file. Because
Mhm.
\n just typed as a text in there is not actually the escape sequence. It is
Right.
text.
Okay, thank you.
Uh-huh. Yeah, and so if I had that, because on that demo.txt right here, this would be that \n. Because that line 9 doesn't have any text in it, but it's an enter key press. And so we'd read that, oh, that's an empty line, do this.
Hmm. Okay, thanks.
Yep. Yeah, great question. Thank you. Okay. So with the IO controller, this is something that I want you to have in your notes. So at least take a screenshot of my screen, preferably of your own code. And what I want you to do is I want you to write down, oh, here's what's going on. Tappy, 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 or righty, righty, righty. This is something that you need to be able to explain with your mammals, how to read from a file, whether it's as a string, an array list of strings, which are objects, which we'll be working on later, but how to read from a file is a skill that you will need to work with your humans on. I encourage using the try-catch style, but there are other examples that we'll see in one of the other videos where you can just throw stuff. I don't do that with my class at all. It's on one of the videos of the text I showed that's in on BlueJ for the demo. I'm not writing it. It's just code I used. It wasn't my code. My code will always have try catches, but you can just use throws. When we get to that video, I will pause the video and we'll show you what you have to do to make that happen. Because, yeah, I'm not going to write that myself. So when you've got your read string from file logic, at least as a screenshot, preferably written down, and explain to yourself so you can explain it to another human. Give me a thumbs up so I know that you're ready for that.
I have a quick question.
Please.
Um, how did you get the results to display in your console window initially?
Yep. So I have my little helper method demo read from file,
Hmm.
and I just grabbed the data using the static method call. So this is like math dot, like we were, I believe it was Amina who was asking about that earlier. And so it's like, oh, I'm going to use the static method call. I'm going to say, hey, IO controller. I'm not
Hmm.
making an instance of you. I just want you to use your read string from file method. I'm going to send
Right.
it that text,
Yep.
store that in the data, and then I just output that string variable to my system.println.
And did you click the green play button?
Uh-huh. Yep. The play
Okay, I
button
get
without the red green line underneath it.
the bigger one. Yeah, I get the selection cannot be launched and there are
There's
no
no
recent
main.
launches.
Okay. So here's what we want to do on that. So first thing we were going to do, we're going to go to your, I'm doing command comma to go to your preferences and go to run/debug and then the launching triangle and click on it and launch the associated project. Have the checkbox in launch the associated project. And so that would tell it to, if you can't launch if there's not a main in this file, find the main in this project. And that should hopefully take care of it.
So just under launch operation?
Yeah, under launch operation, the checkbox should be under launch the associated project. Exactly.
Okay.
And if that doesn't work, then go to your runner.java and hit play on it. And that should teach it where your main method is.
Yeah, now it's giving me a run configurations list. Fun stuff.
Did you click the triangle like that?
Yeah. Oh
Okay,
no,
because you've got,
I clicked the button. I clicked the button.
okay. So, and if it pulls up the run configurations right here, like this,
Yeah.
so you should have, if you don't have a main method in here, so this is, we'll close that. On your public class runner, do you have a public static void main named properly? Like
I thought I did.
I've done this wrong myself more than once.
I
I'm like,
mean, there's a space in between the main and the paren. I'll
right.
take that out.
Yeah, that sometimes shouldn't cause a problem, but hey, we'll throw, white space should be ignored. Should.
And then control that can have that start. Yeah.
Try just deleting the header of the method and rewriting it. So just rewrite public. So delete the header, hit save, and then rewrite the header. The name of the variable does not matter, but args is traditional. So that sometimes has fixed errors like that.
Hmm. Still just in run configuration, but I can look into it later.
Yeah, if there's nothing that comes up, let me know. I can try troubleshooting with you some more too.
Sure.
Cool. Um, but yeah, oh, I click the yeah. So now you see this red green line right here. I accidentally clicked this one right here for the code coverage. Oops. And so I can close that. Yeah, close, 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 reopen it. And the way to take that off is coverage. And I take that and I hit X and I take those off and I somehow hit the coverage button and get rid of all of them. Yes, yes. Okay, and that goes away. I've done that before. If you get that code coverage one and you just go to the coverage window and it'll turn off all those things, that red green coverage. That's
Mhm.
for test purposes. Don't need to worry about that. It's just, yeah, I've done that myself. I didn't realize I actually clicked it, so good for me. Okay, so we made our controller and our IO controller. So we made it so we could actually do something with file content. And this is one that's like, oh, here is something that you will definitely want to practice with your humans on a fairly regular basis. This is something that they're going to have to do. But reading IO, reading data from a file and working with it is so much better than typing file information in. I don't know about you, but I don't want to type in a whole bunch of garbage for students to process or have the students type in a bunch of garbage for them to process. But if I made, say, for example, I copied text from some web page and pasted into a text file and did some random, editing on it or whatever, I can give that to students no problem. That's not me writing lots of stuff. But if I want to have something that students work with, like say, for example, War and Peace and count all the thes in it, I don't want them to try and type out War and Peace and count the thes as they write it, or read War and Peace and count the thes as they read it. I want that all done by the computer. And so giving students text files, easy peasy stuff. And then having them do stuff with it, they can now use that. Here's that text file they just read. Now they can do all their string logic on it. They can count all the thes in it. They can have their count the sentences. How many times do you have a exclamation mark? How many times do you have a question mark in that file? How many times are commas used? Whatever. You can do all those algorithms. You have to be able to work on a string with a file, which are way better than I can see the string on my, I just typed that string up myself. I can count them myself. Why would I use an algorithm to count that? Because we don't we don't want to do algorithms on things we can see with our eyeballs. We use algorithms to make our computer life, oh, the computer can look at the entire file for me and count them. It's more than 5 or 10. Computer should do it, not people. It's more than 100 things. Computer should definitely do it. What's the most you've had your students type that's not code specifically? 5 things? 10 things? Do you want them to type 100 things? They're going to get annoyed too. And so this is where we can use tools to make life easier for all of us. Questions about doing file IO with string in Java. Okay. Wiggle your shoulders. If you haven't taken a drink recently, take a drink, please.
Where do your recordings reside on? Is it on Canvas?
Yeah, so if we go over to Canvas and we pull this up here really quick, I actually have the screen already right here. So there's a video module down at the bottom. There's Monday's video, the Tuesday morning video. I'll have the Tuesday afternoon video posted there after class.
Okay, thank you.
Yep, of course. I have a window just for that on my screen so I can make sure I link it back up later. Okay, who thinks they can introduce file I/O to their mammals? Okay, good, wonderful. That's real. I think that's a great thing. We're going to come back to file I/O again tomorrow as well, because file I/O is kind of a critical thing. But we're going to switch gears here and go to Unit 3, the one that has the least amount of code tested on the entire exam, 10%. But it's not actually 10% because you use it everywhere. And so class design is our next piece. So Java is a very forgiving language for writing classes. When I write a class in Java, I can put things anywhere I want. Java doesn't care. One of my students in my master's program, when I was doing my master's degree, she went to school in India, and she had all of her data members. They were always at the bottom of the file. And I'm like, I've always put them at the top. And I'm like, well, that's how she did it. And like, so when we were working together on our group project, it's like it's like, okay, it's like for your when it's if it's you own the file, we'll have them down here. If I own the file, we'll have them up here, and working with different code styles. But it's Java doesn't care. I had a student who, in their inestimable joy, interspersed their data members throughout the entire file. Some at the top, some between methods, some at the bottom. There was no pattern. As soon as that student got the idea, they put the data member. I was not a happy human with that human. It's like, I'm not troubleshooting your code because I don't know where that variable is right now. I don't want to have to try and find that variable. Put them all in one place. I prefer at the top, but if you want to put them at the bottom, that's fine, but put them all together. Now, when I write my code, I tend to group my variables, the data members, by type. Here's a bunch of strings. Here's a bunch of ints. Here's a bunch of cars. Here's a bunch of whatevers. So it's like, oh, here's these types of things that I'm working with so I know what they are. Or by functionality. Here's all the things that relate to this top. Here's the things that work for this thing. And I group them by functionality as well. But the actual order, Java doesn't care. You could do it alphabetically. I would not recommend sorting your variables, but you can do that. The one thing that we do care about is data members, instance fields, properties, attributes, or any of the other vocab terms that describe them should all be private. And that's talking about encapsulation and how a class is designed, because we don't share information that we don't have to share. Am I allowed to crack your skulls open, poke inside your brain, and make your body physically react to things? No, that's a bad thing. There's rules against that. We have actual like student experimentation's not allowed in the United States. We can't do that. There's human rights violations about that. That's bad, bad, bad. Can I go up to your house and paint polka dots across your front side of the house? No, that paint color, your paint of your house, that's a private value set by the owner of that object. And so private data belongs to that object, not just anyone that can get changed in that. So private belongs to who that has. And so I use body autonomy. I use regular property type things that we don't just change of other people's stuff, and use that as an analogy to help talk about that concept. Constructors, they can also go live anywhere inside the class. For convenience sake, I put them at the top. Java, if you don't write a constructor, will give you a zero parameter constructor that does nothing. It's not actually helpful, but you can do it. Or you can make your constructors have parameters, and you can initialize data members. And oh my gosh, that's amazing. You can do all sorts of cool stuff with that. One of the exercises that I do to share that is my marshmallow monster or snack monster project. Now, y'all aren't here with me. I can't give you a baggie of treats and say, hey, go build a monster. But if you go to the monsters object link right here, and it's you'll make a copy of the APSI snack monster project. I'm not going to hit copy. I'm going to go to the root directory. This year, we are doing it as a snack monster type. So so it's like you have to figure out some things. So you want to make a snack and you make a monster for that snack. And what I would do normally, I'm okay spending some money on my humans. This is not going to be huge money. Again, do not go broke being a teacher. I can afford to spend 40 bucks for my humans on ridiculously bad food of candy, marshmallows, and some baggies. I buy the no-name brand baggies. I buy the cheapest big bag of marshmallows they have. I buy a bag or two of the really cheap pretzel sticks. And then random candies in the cheap section. Thank you, Siri. Privacy settings. Somehow I tap that. I don't know. Okay. But I buy a bunch of candy. Small things, put them in baggies, share them out. Or in the case of this, we're going to do Snack Monster. And it's like, I want you to go make a little snack, a little something, something for you. And what you're going to do is you're going to make a monster out of it. And we're going to identify what those monster requirements are. You have to have at least 2 ints for your monster, maybe an eye count or teeth. You have to have at least one Boolean variable about your monster. Is it spooky? Is it silly? Does it have a nose? You have to have 2 double variables about your snack monster. This could also be a laundry monster or any other thing that you want to play with that you have with you right now at your place. Because this is something that you can just do anything with. I use sugary food because giving kids sugar and then having them go is fun. But you're adult humans, and I can't give you sugar right now, but we can still pretend. And you might have sugar you like at home, so that works too. There is one string variable they have to have. They have to name their monster. And so what I have the students do is they have to design their monster first. And so we have our questions right here. And you're going to define what kind of snack monster you want to make. Answer that question in the document. Okay? Identify that the data member is what you're using for. So you have a data member and what data type it is. Again, you have to have at least some of those options right there. And then write down the items you're using for each of those data members. So, oh, for my eyes, I'm using this. You don't have to have an item for a name because the name is implicit in the structure. But like, okay, here's what we're going to do. And you're going to then, after you do that, you'll write the code for your parameterized constructor to initialize all your data members. So if you're going to say, oh, here's the code that would make that constructor and make that happen. So write the parameterized constructor out and paste it right here. And so this is not inside the code. This is not inside Eclipse that they're writing the code yet. This is inside their notes, and they're just pasting it in here. Eclipse will happen afterwards. So this is the writing code that they would need to use, and then before they actually put it into the Eclipse project. Write the code that will create your monster that you want to make using these things that you're working for up here for the values that are working for that. Okay. And then you're going to take a picture of your snack monster, clean up and consume your snack. Now, as you can see, normally in my project, I use the package structure with monster.model, monster.controller, etc. We don't have to worry about that right here. It's just I literally took my assignment and turned it into the APSI one. So you don't have to make packages for this. What I do want you to do is I want you to make a monster.java file after we get your monster put together. And so I'm going to quickly make a monster. And I want you to find something you can make a monster with. It can be just drawing it on paper. I'm totally okay with that. If you don't want to have a snack right now, that's fine. You can just sketch out a really stupid monster. Like, oh, here's my arms. Here's this and this. But you're answering those things out to actually put those questions on. Because it's a activity type thing. I know, crazy. But we're going to make a monster, whether it's actually consumable or not. I just ate lunch, but and some of you also just ate lunch as well. But it's like snacks are also something. If you're actually hungry, great time for a snack. Um, because snacks are yummy. But you can also just sketch something out. You can use laundry. You can do whatever you want. But I want you to put together that thing and answer questions 1 through 7. You do not have to consume your snack if you didn't make a snack. Obviously, don't eat paper if you're just drawing it on paper. I'm not that evil. And if you're making stuff with, say, for example, laundry, we don't want to eat the laundry. That's bad. But what I want you to do is to identify the pieces, put it together, write some code. If you have questions, I'm right here because I'm happy to answer them. But I want you to see if we can do that, and I'll put the assignment link for that inside Canvas as well.
Cody,
Yes.
so I've done this activity and it
Cool.
usually, well, in the old version, it would happen sometime after the Thanksgiving break and before winter break.
Mhm.
So we made snow pals, right? I mean, like snowmen, but okay. This is in what unit now? Is this unit 3?
Unit 3. Mhm.
Okay. So if you're not going out of order, I mean, I know you go out of order.
Uh-huh.
So do you do like most of 3 like kind of during one, or do you do so like you do a little bit of 1 and then bounce into 3 and then do a little bit of more of 1 and
Lots
then
of 3, bounce into 1, lots of 3, bounce into 1.
I got to figure that out. That's part of my planning. I got to
Yeah.
get farther into the newish content
Mhm.
to
Yeah, so I
figure
do
out
this
how to
project
do that.
usually mid-September. I start
Okay.
in August.
Okay.
And so I do this when it's usually mid-September. It's before Halloween because I'm using literally the cheap rando candy that's at the store.
Yeah, well, I usually get the cheap candy that's designed for like gingerbread houses,
That works
right?
too. Yep.
So
Mhm.
yeah, I mean, like you get a big bag of Red Hots and little mini chocolate chips and
Yep.
whatever, and works great.
Yep,
All right,
exactly.
I just got to figure out where this is going to go. Okay, thank you.
Yep, no, great question. Thank you. And the assignment is linked now inside the programming module. Make a copy of this so I can type on it with you since I'm actually doing this assignment. Florp. Copy of Snack Monster. Data member. Arm. Data type. Int. Eyes. Int. Or eye count. So I just did my data members and my variable types, figuring out what I'm going to do for my monster. So I'm planning out what I'm going to do. Now I have to go ahead, I have to write that code for that constructor. And so again, I'm writing this right here. I see there's a comment in chat. One second. Let me just go over to the chat window. Sorry, it doesn't stay open. Okay, I will check on that. The video should be recorded. I'll see what's going on that. One moment. Back over here. Video is published. Hit refresh again. Are the two video links showing up on the video canvas for y'all on the modules page?
I saw it, but I didn't try to open it up.
But it does say video.
Yes, I did see that.
Okay. If it says video and it has a down triangle, it should be there. So Kai, try checking that again and hopefully it should be there. Try relogging in. If not, I know they're uploaded, so I will try refreshing that. See video but no contents. Oh, boom. Sorry, I didn't hit the checkbox. They should be there now. Hit refresh one more time. I thought I hit publish all. I hit publish and only the title. Should be there now. Yay! Hooray. Cool. Like, thought I had to hit publish all. Okay, so I'm gonna write my parameterized constructor. And so again, I'm just writing straight here in this. I'm not writing my code inside an editor because I want to practice writing code that's not in the tool because I have to make sure I know what I'm doing. So it is a public snack monster. And I need to fix that P. I already know that. And squigs. Boom. So I've got that stuff right there. And I need parameterized constructors. So I have to give it this parameters. And the order doesn't matter as long as I keep track of it myself. So I'm just going to go down this line right here because it's works for me with that. So string name, comma, int arm, comma, int leg count, comma, excuse me, please. I burped. Int arm, no, I count, comma, double scare percent, no spaces, scare percent, comma, double fur coverage, and my Boolean was has nose. And let's see, how my peach shrink by my nose. So has nose. Oops. I forgot that I had a nose on there. And now I need to initialize them using the this variable equals parameter. So space, 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 this dot name equals name, semicolon. This dot arm equals arm, semicolon. Oops. This dot leg count equals leg count. This dot eye count equals eye count. This dot scare percent. There, that looks kind of like code. And so I've got my code for my parameterized constructor to initialize all my data members using the this dot variable equals parameter pattern. The Java CED, APCD doesn't require us to use this dot. I do. That's one of my style things. I'm like, oh, the this dot says I'm talking to my data member, and that way my data member can have the same name as my parameter. I can explicitly know that I'm using the right piece. Like, oh, I'm assigning the arm to the arm of the object. I'm assigning leg count to the leg count of the object. So that's something that I work with on my students early on. Like I said, I do 3 early, and this is one of those things I'd be doing like at the very least. This is the latest I do. This is by mid September with that. So it's like, hey, we're making this object. We're doing a little bit more than simply just a quick object. Here's a object with lots of data. So I've written that out. So now I've got to build my snack monster. I have a monster. Don't have any candy with me because I didn't pack candy to bring upstairs because I'm trying not to eat in my office. um, so when I do this in the classroom, I have wipes easily available. I have the students wash their hands before they go do this. I have them wash their hands after they're done with this. If they don't want to eat their candy, please just throw it away in the garbage can nicely. Um, please don't touch the computer with sticky hands. These are humans that we're used to talking to. You have to explain those kind of things to them, but I explicitly call that out a few times as we go through that. And then I give them the baggies of the stuff. They can make their project. And then we actually write the code for this that we can see right here that's listed inside absent work. We're going to make that project, and I'll start that here with you in a few bits as well. Who has made progress on their copy of Monster Assignment? Who's using a snack type? Who's using food to make something? Anyone? Who's drawing on a piece of paper? Okay, fantastic. It's that's what I did today as well because it works. But you can definitely use actual snacks with this, and it's a lot of fun. The COVID year when I did this, it was completely at home. It's like, hey, you're going to eat a food anyway. This is what you're doing. Make your food according to this. Since I'm at my office, you're at home. I can't see what you're doing, so you're going to turn your food into your monster. But it's this is something that it's very adaptable. And so with the take of the picture of the snack monster, I'd have the students use their phone for in the last 10 years, I've had, I think, 3 students who don't have phones. Most of them, like, we just take a picture of my monster for me. One student, do you want me to take a picture of your monster for you and email it to you? Yes, please. But most of the time, it's like, yeah, I can just take a picture of that. They email the picture to themselves or they text the picture to themselves, whatever they want to get it on there. Because some people, like, they'll work with Google Docs on their phone. I don't work with Google Docs on my phone. Yes, I have the Drive app on there, but it's not so I can actually work on the app. It's so I can find things and email people when I'm at work. But I just have them send a picture themselves. They put the picture in that, or they'll pick their monster up very delicately and bring it in front of the monitor, and then use the picture taking app of the camera on the screen in there to do it that way too. It's like there's my picture of it. And I was like, cool, great. Just don't drop it on the keyboard, please. But however they want to get that picture in, I'm cool with that. Put it into a PDF. And again, this is they're writing stuff that doesn't have in the grading that's on this. There's not a lot of extra work. It's like, oh, put up on screen, graded, graded, graded. There's no, I can see immediately if they have all the pieces they have to have. I don't have to spend a lot of time reading this. It's just there. I'll be right back. All right, how are we doing with our monsters? Thumbs up, fantabulous. And so we're going to use this to actually go and create another project in Eclipse so we can practice with making objects and doing the structure of a class and learning more about that. And so if you want to start making that project right now, go ahead. If you're at that point, if you're not, if you're still working on answering the questions 1 through 7, that's great. Keep working on that. We've got a couple more minutes and we'll go from there. Oop, oop. Okay, how are we doing on steps 1 through 7? What number are you at? I see a
I'm on 5.
5, couple fives, fantastic. So I just want to check on status. In person, I'd be walking around and seeing this, but obviously I'm not there, so I'm here, but I'm not. Can't do that. It doesn't work here.
Cody, could I see your controller class?
Of course. There you go.
Ah, cool. Thank you.
Yep, yep.
So the reason why you have it as a class of its own is just for like you just wanted to be tidy and have less of, is that all it is, or
Yeah, and this is where I'm going to tell the marshmallow monster what to do, or
oh,
whatever other project I'm working with. The controller class is the manager of that code. It's like, oh, here's I'm telling this, I'm going to tell the start method we'll call the add numbers method. The start method we'll call the display results method. It's going to be the thing that's going to be, say, for example, like the director of a play or a movie. It tells the other pieces where to go.
Cool. Thank you.
Mhm.
How's that different from a runner?
All the runner does is starts the project. So the runner has a main. Main calls the controller and tells it to start. And so the runner is always just those two lines of code plus the main header. That's it. Checking to make sure my wife ate lunch since she forgot yesterday and I barely remembered. So send her a text. And the only reason I remembered is because I sent you to lunch and then went and did the laundry. And they're like, oh wait, I'm supposed to have lunch right now too.
Cody,
Yep.
I know you put the controller class up once.
Uh-huh.
Can you put it up again?
Happily. Of course. I'm going to put it back up.
Okay,
I
there you go. Okay, no, that's the runner.
Yep,
I
sorry.
did the runner already.
Controller.
Okay. Because I don't usually do it this way, so I'm pushing myself.
Cool. I'm glad to hear that. That you're pushing yourself.
And I'm
The-
trying to figure it out.
Yep. I was just going to take a picture of my monster so I can put it in my assignment too.
Cody, what goes in the assignment thingy? What do I put there?
That's just the PDF of your copy of the monster stuff. So just
Oh, okay.
download as a PDF and plug it in.
Cody, can I ask again? Because I know you've said this before, but why is it that you don't have the students code stuff in main? Why do you have the controller class instead?
So the purpose of main is to start the project. It is Java's entry point. And so It's like I'm showing my face here. I'm like, no, I don't need to show my. The only thing that main basically is designed to do is start that project and do nothing else. And so I don't want to troubleshoot while your project isn't starting. So if your project starts the same every single time, that's one less thing to troubleshoot. And the because it's just, oh, start your project. That's all runner does. And then your controller or your project app name will be, because I used to have like project controller instead of just controller, and I shorten it always just using controller. It's like it is to tell other pieces of code what to do. And it may be processing stuff itself, like especially in our early project, it does a lot of its own lifting as well. But it's like, oh, here's where the work happens. But like things that belong to something else, I'm going to send that code over there and it's going to live in that space. And so all the stuff for Marshmallow Monster lives in Marshmallow Monster.java. It tells it how to do all the things. All the things about input output live in IO controller, and it does those things. Trying to make it so that there's the least amount of coupling of logic together that I can possibly do. So like each one thing does what it has to do well. And so it's small piles rather than big piles for the purposes of easy life.
So you basically teach your students how to do classes, like full on whole part classes almost right away.
Almost right away, yes. Like the first, it's like they don't do very much at first. Like runner just starts the project. Like that's all that class does, and that they don't. I don't explain why main works the way it does. I don't. It's just like this is code you write every time. And the controller like, oh, let's make a method to do this, and like, so rather than having everything in one giant pile of main, it's like, oh, let's make, and it's like, oh, we've got a lot of code. We should maybe turn this into like its own method because we want to do this more than once. So let's do ask questions again, and so it's like we'll call ask questions twice, and it'll do the same thing twice. So it's using the idea of basically object decomposition early on, but not going into all the details until, and then we start getting more details with the monster project.
Okay.
Yeah, great question. Thank you, Tara. And then I was going back over here to Chrome. Yeah, there. And take a picture of my snack monster. Insert image from computer. Desktop monster. Blorp. Ha! See, I can do the assignment too. And we'll call this one Augsburg. APSI monster. Boom. Is it URG or ERG? URG. Okay. Okay, so if I were to download that as a PDF, doomp, download as PDF. The PDF has been downloaded. Hooray.
Cody, is encapsulation part of the CED
Yeah,
things?
yes. That's part, let's see if I can find the actual reference to it here. 1 second. That's a great question. Aha. CED. ENCAP. Data encapsulation is in topic 3.3, anatomy of a class.
Cool, thank you.
Yep. Yeah. No, I don't need this window open. I can close that. Yay. Closing a tab. Hooray.
Cody, my drawing is atrocious and I hope it makes you laugh.
I guarantee I'm going to love it. I guarantee it's also not atrocious.
I keep looking at it and I just keep laughing.
Okay, let me get back into Canvas so I can take a look for it.
I mean, it's not like groundbreaking, but I failed middle school art, so every time I draw something, it just reminds me of my lack of skill.
And this is where I have drawing assignments with students occasionally, and it's the drawing is just like code. Practice is done by work and repeating it, and that's how people get good at it. No one is good at art implicitly.
Never feel bad about drawing. They had me, I was another one of those that failed art class. In fact, by the middle school, they gave me a D just so they didn't have to have me again. But they had me teach geometry. Yeah, I don't know what they were thinking. By about the end of the third week, my students actually set up a rotation of who would come up and draw this stuff for me because my drawings were so bad.
I have
So
that
I
right
actually
now in
decided it
geometry.
worked in my favor.
Yeah, my kids do that in geometry. They're like, "You call it a square?" I'm like, "Well, you can do it then."
Yep, that's exactly. I'm like, just use your imagination. You know what it should look like.
Exactly.
Fred is adorable.
Yeah, it and even my students now, like now that I teach woods, I'll have to draw out stuff to show dimensions, and they're like, Miss Cootie, that is not straight. I'm like, use your imagination. It's close enough.
I love Costa as well.
Yeah.
Thank you.
Thank
Thank you.
you. No, it's like students have so much fun with this. Like I literally get amused all the time at what students create for this.
And it's fun for us too, because then we can see like who actually has a knack for what. And, like just to see their creativity is
Mhm.
so much fun.
Yeah, I've had students they've like my monster needs to walk, and so they've like so I normally use pretzels like I said, and it's like okay I use pretzels to connect the marshmallows together because the default constructor for a marshmallow monster is just two marshmallows that do nothing. It's like this is not
Mhm.
scary, spooky, silly or anything. But if you just stick them together like at an odd angle, oh, it's now funny. Or you can make it look evil. And it's like, okay, so I've got this multi-legged, droopy creature that's like looks like it's crawling on their paper plate or their cardstock, whichever I happen to use for the surface for that assignment. And it's like,
Mhm.
that is insane. Its name is Fred. It's Mr. Sprinkles. And it's like, good job. And then I'll have one that's like it's a mass of sugar just like squished into itself. That's like it's everything in the thing but squished together. I'm like, I can see that. Are you gonna eat it? No. Like, good, actually. Jamie, can you re-upload your PDF? The second page is um not a PDF.
Interesting. Yes, you can do that. I can
It is
try.
an empty screen. And I'm like, that's not what it's supposed to be.
It's supposed to be a picture, so
Yeah.
yes.
Yeah, it was an empty screen. I'm like, that is not a PDF.
Thank you.
Yep. And Monster Cookie is someone's monster. I don't have their name. Their canvas name is 1074030037664457386. Check to make sure you have a name for your Canvas account. I don't know who you are, but you're a number. I've got two of you who are just numbers. So if you want to check to see what your Canvas is named as, if you look at your Canvas account, I would love you to have more than simply just a 18-digit number. I can go and research who you are, but I'd prefer if you can just go to your Canvas account, make sure you have a name instead of just a number. It makes my life easier. And for those of you who've turned in your code, or not your code, your assignment, if you can start by making your project with those three files, runner, controller, and monster.java. And I will put all three on display so you can see all three of them. Because the nice thing about this is I can have everything we've done right now all on screen. And that's one of the things I like about Eclipse is I can show lots of code windows at once too. Be right back. A delivery just showed up at my window or my door. All right. Who has gotten past step 5? All right, so we're going to go ahead and work on actually doing the class creation process and how we can use said class in another class. So again, it's the idea that we're doing that process of building code together and making it so it's even cooler at every step of the way. Because it tends to be that if we make stuff better, life is happier. So again, we make a class with that same keywords, public class, and then the name of the class that we're working with. Now, this is something that reflects something that we're building. This is where the idea of object-oriented programming comes into play. We're making objects that reflect something in the real world that can do things. This is what I would call a model class, where it's a model of something we've made. In this case, it's our cute little monster. Okay, so we have the code that represents this kind of thing, but it'll also represent your individual one, your monster, their monster, people next door's monster. All that stuff can be represented with this object. And that's the power of code, is that even if you have different monsters, I can still create all those monsters together using code. So I don't have to write the same code 8 billion times. I can use this code multiple times because I've said, oh, here's all these pieces I want to make, versus simply putting this as a string would be a lot more work. And so we're first going to make the data members, the things that describe that monster, its attributes or its properties, its instance fields. And depending on which textbook you're working with, you have a different variable name for this. I try to, especially early on, like, hey, here's a bunch of different variable names. I use data member as my default because that's the one I like. But here's a whole bunch of variables that are vocabulary words, excuse me, that meet that same standard. And whichever one you like, cool, great. But there's others, and it's okay if you see other things, don't freak out. Just recognize there's other ways to talk about the same stuff. So we have some data members over here that we already had. And so we have the idea that we had some things with that. We had a name on that for sure. And because students get to choose which pieces they have, it's like, okay, don't follow what I write. Write what's on your document. And so I'll have my document on one of my other monitors so that they can see that. And so I have my string name. Oh, that compiles, that's fine, but there's something missing. What's missing here?
Private.
Private. And it's like, it's like, it's not critical, but it's important that we always start off with that process, that we always use good coding practices. And it's like, and like asking like silly questions like that, like, hey, what's missing right here? And using that to help the students guide that. So these have to be private. So only the marshmallow monster can see this. No one else can see what's inside that box. We can only share stuff separately. We'll talk about sharing that in a minute. And then I have a private arm count, or no, I had just private arms. And I had private leg count and private. Oh, I have to give the type on there. Int, have to specify what things are. Int, private int I count, private double scatter percent, private double fur coverage, and private Boolean has nose. Okay, so I've got all of my data members specified. Now, data members, if they're primitives, they have a default value of either 0 or false. But my string default value is what?
No.
Null. And what happens if I ever touch null? What happens to my project usually? We crash, we burn, we die. And we don't want to touch null, so we have to give values to things that make sense. So we're going to make a zero parameter constructor that can give us default values that are helpful, because the one that Java gives us won't help us. And then we'll make a parameterized constructor that will give the values that we want to have. So first we'll make our zero parameter constructor. So public marshmallow monster. And remember, marshmallow monster does not have an E in it except in monster. And I'm going to say this dot name equals quotes and unnamed. And this dot arms equals -10, because you can't have -10 arms. Negative things that are counted can't have negatives. You can have 0 of them, but you can't have negatives. So talking about why it's like, oh, this is clearly not a valid number for it. It's something that's wrong. And this dot leg count, and I try to use the same order that's in right here because it makes it easier for my brain to process it. Again, decreasing the cognitive load as far as I can every step of the way. Equals -1, not equals like that, -1. And this dot I count equals integer dot min value. That's another good default value where it's like, hey, it's impossible to have -2 billion of anything. So like, hey, there's another way we can, and I sometimes will throw that in. It's just a nice little thing to introduce that. Not a requirement, but just like showing, hey, here's another value that can work. Now, scare percent, negative is totally valid for percentage. So this dot scare percent equals 0.0. That's fine. That specifies only 1 digit of precision. And this dot for coverage equals 0.001. I have 3 digits of precision. And we'll talk about what that means and how that, oh, the number that's after the 1 is guaranteed to be a 0. The number after that is guaranteed to be 3 or less. And the number after that, I don't know. But that's it. And I talk about that in my lectures and demos. And this dot has nose equals false. There's only 2 options right there. False makes sense. So now if I were to make a marshmallow monster object, it has values in it that are stored in the state. I can't access any of that. All that stuff is private only to a marshmallow monster, and no one has access to it. So first we're going to make it so I can make my custom monster, because I want my monster to be the one that I made or that you made. So we can make it so we can make that. So that's where the parameterized constructor comes into play. So we're making another constructor. What's that vocab term from your reading the other day? This would be, of course, inspired by the Heather reading. When I have something with the same name, but different parameter signature.
It's not polymorphism, is it?
Not polymorphism. I heard it a little bit behind someone else's voice.
Overloading.
Overloading.
Overload, yeah.
Overloading. So we're going to overload the constructor because we have different needs for different constructors. The zero parameter constructor is when I want to make a default object with no specificity. An overloaded constructor with parameters is when I want to make a custom object. And so custom objects are usually what we want to make, but sometimes, especially when making, like, say, for example, I want to give everyone a monster, they can customize it for themselves. So we make one monster, we just give a boring monster and they can make a custom, or as we go through that, we can make custom monsters. Where is the window? There we are. Sorry, I had to figure out which screen it popped up on. And so we can have that customized constructor that allows that to happen. So we'll go ahead and we'll write that custom constructor. We just wrote the code for it on screen. I'm going to do it again right here. So public, and it still is Marshmallow Monster. And squig. And I can't just leave it like this because that's the same signature. It doesn't have any parameters. So I have to make sure I put all the signature parameters in there. And you can do this as multi-line if you want. You can remember, because Java is a nice language. It lets you have however many lines you want for things. Where's my cursor window? There we are. Squish that out of the way. And so we're going to go over here and I'm going to just follow the same pattern like this, because again, decrease cognitive load. Make it executive dysfunction as minimized as possible. So string name, comma, int arms, comma, int leg count, comma. And I'm going to go over here, int I count. You can press enter on that, it's totally fine. Double, scare percent, oops, not capital. Double fur coverage. And Boolean has nose. Just close that out of the way completely. And there, I've got that. I can set that as multiple lines if I want. I can have it as one giant line. That's totally fine to make that happen. This is just to make it so it's easy for me to display on screen. Having it as one line is fine. You can do it as 8 lines if you want to. That's totally fine. Because remember, Java doesn't care about white space. We just want to make this so it's easy for humans to read. We write code for humans. The computer just interprets it. And then to assign this parameter to the data member of the same name, that's where we have the this dot in front of it. So this dot name equals name. If I did arms equals arms, Eclipse gives me the yellow underline of uselessness. You just wrote code that's not helpful. Because I just said that, hey, arms, you're the same thing as yourself. And I'm only talking about the parameter. I'm never talking to the arms up here, the data member itself. And so by using the this dot on the constructor, I'm explicitly calling out that, hey, I know I'm talking to the data member, not the parameter name. And so also you have the, with Eclipse, I have the nice color change right here. So I have the lighter blue versus the dark blue. And what Eclipse nicely does is when I click on something, it highlights all the other occurrences of it. So name is right here and right here, but that's different from this dot name. And so go and do that for all the things. So this dot leg count equals leg count. And if I go out of order, I could skip things. So that's why I also just follow the same order as the data members as the parameters, so I don't skip anything on there. So this dot I count equals I count. This dot scare percent equals scare percent. This dot fur coverage dot slash fur coverage equals fur coverage. And this dot has nose equals has nose. And so now I have my custom constructor, my parameterized constructor, that can assign the values that I want from my cool monster, or my silly monster, or my spooky monster, or my ridiculous monster when I create it. So this is why a parameterized constructor can be very helpful, more so than a default constructor. Another package, hooray. Now, that private data belongs to my monster. It knows about it, but no one else does. Because it's private, there's no way of accessing that. So instead, I have to now make ways to retrieve that information. There's a fancy name and a normal name for ways to retrieve that information. Who knows either the fancy or the normal name for that kind of method?
Getters and setters.
Getters are the way to retrieve it. That's the normal name. Who knows what the fancy name for a getter is?
Accessor.
Accessor method, yes. And accessor methods or getter methods are really easy to write. Getter is what I call them by default because it starts with get. And so it's going to be public type of the variable, string, and then get name using camel case. And so this is a great way to practice that camel case and why we do that. And it has exactly one line, return this name. And guess what I'm going to do for arms? What's that going to be called?
Public int,
Public int,
get arm.
get arms. Yeah, not why not public string?
Wrong type.
Wrong type, exactly. And return this dot arms. Boom. And so it's like, okay, I need to make all of these things. And it's like, okay, students, make all your getters and set all your getters. And I have them do that. Now, what if they ask, like, why do we have to make these ourselves? Muscle memory again. Can I just generate them? No. Again, if they've explored the tool and they know that you can actually have Eclipse auto-generate all those values for it, that's wonderful. It's great. We're not teaching that. It's like, I want you to practice making sure you have access to the things you need access to, so you're going to write them. And so I go through and I write them with the students as well. I'm not writing all of them today. Now, someone else also said there's the setter methods. That's the way I can change things. What's the fancy name for a setter method?
Mutator.
Mutator, yes. And so those ones are always public void for the return type. And it's going to be set and then variable name. And it has a parameter of the type, name. And the one-liner for it is this dot name equals name. And you would make setters for all the ones that you want to be able to potentially change. And that's great if they have that default constructor. Now they can say, oh, my monster's not a boring monster anymore. It's a goofy monster. Its name is Derpy Derp. And because I now have the ability to set all those values, regardless of what type it is, it's public void set and variable name, and the parameter will match the data member type. So public void set arm count, or leg count, and int leg count. And this dot leg count equals leg count. Oh, okay. And it's like, oh, I just go through and use the exact same order that I did earlier again with the data members, with the initialization and the default constructor, with initialization and the constructor, with all the getters, the same order with the setters as well. Now, you're adult humans. I'm not doing that. You don't need to watch me do the same thing again and again and again. But with your students, they do. And that first time I actually step them through it. And now that I've got my monster, I'm going to go and work with my monster in my controller. So I'm going to go back to my controller.java. And I'm going to go ahead and I want to make a monster object. And again, I usually farm these things out to something else. So I'll have a private method. It's a void method and work with monster. And I'll call that in start. So again, it's like the start method is going to start the program. It's going to go over here and do this, and I can have whatever I want in start, but it's like I'm farming out code into smaller piles so I can see what I'm working with. And so I'm going to make a marshmallow monster. Boring equals new marshmallow monster. And marshmallow monster special. Let's see. So string, int, double, double, Boolean. string int, double Boolean. Oh, monsters. Silly Cody. And not capital M. Ah, silly Cody. Typos are not your friend. Craziness. Okay, so I have boring and special. And so I've created these monsters. I want to work with them. Well, let's print them out. System.out.println. Boring. So I've got printing out boring and special, right? And I'm going to print that out, and I'm going to get marshmallow monster @ gobbledygook. Marshmallow @ gobbledygook. That's not that helpful. The default toString is useless to all humans. It tells us the name of the class, followed by an @ and the results of the .hashcode method, which don't help us. So let's make it so we can actually talk about monsters. I'm going to go back to my same thing. I'm not going to change any code in my controller. I'm going to go in my marshmallowmonster.java file. I'm just going to squish all this code down so it's out of the way. Doop doop. And I'm going to make a toString method for it. And the toString method is one of those methods that Java already has, but we want to make it so it's better because the default one, as we saw, not that good. So public string toString. And my rule for toString is you have to use at least half of your data members or 3, whichever's more. And so I'm going to say that my string description, again, really boring name, equals quotes, semicolon, return description. Okay, we'll finish this and we'll go to break. And I'm going to put that I'm a monster. And description plus equals, not plus plus, the arm count, arms are plus arms. The legs are okay. Just quick little derpy stuff right there. And I'm going to rerun my code and put that back where it belongs. I'm a marshmallow monster. The arms are -10. The legs are -1. I'm a marshmallow monster. The arms are 1. The legs are 2. Oh, I've got to fix my spaces on here, but you can see the difference between those two different constructed objects and what is output from them. Or I could use my getter methods to access individual values out of that data. And so we can do some cool stuff with that. And so I have the students write all the getters, all the setters, practice outputting their code, practice inputting values and modifying an object, and going from there. And this could happen obviously in Unit 3 would be where it would fall inside the APCS subset. And it's like, oh, here we're going to make that monster. We're going to change that monster. And then I want to make a lot of monsters. I'll put this in a loop. So I use the process of loop and printing out lots of monsters. And those monsters get thrown away. What if I want to keep those monsters? Now it's my turn to introduce array list. And let's make a loop and make a whole bunch of array lists and store them in a list of monsters. But that's a good breaking point. I'm going to make my codes visible so you can see all of it, but let's take a quick little break, use the restroom, etc. We'll come back here in 15 minutes. I'll be right back. Gotta do this.
Welcome to Java Lab.
What? All right. Hello. Refresh. Let's go to Peeps.
Cody, could I see your Marshmallow Monster class?
Of course. Let me pull it back up here really quick. Is there anything specifically you need to see so I can make that part?
The string method.
The two string? Yep, right there.
Thank you. Instead of having the arms and leg count, could I just have called the uh what was the get name and
Arms?
get arms?
Totally. Yep. In fact, when I demo this, I actually do that with the students. Yep. Just like that.
I see the end of that line 23, the rest of the parameters for the,
Oh, yes, of course.
thank you.
My pleasure. No, definitely.
Hey, Cody,
Yes.
you're going until 4:30 your time today, right?
4:30 Central Time, so
Yes.
3:30 my time.
Oh, okay, 3:30 your time.
Yeah.
I think I'm gonna need to leave 15 minutes early. I've got an appointment, and
Great.
is that okay?
Yep.
Okay, and I'll just check the video. Well, at least the last 15 minutes of the video. Okay.
Yeah. Yeah.
Thank you.
Totally fine. I understand.
Oh, my camera's not on. Oh, all right. Interesting.
No worries. Yeah, no, it's all good. That is perfectly cool.
Cody, does the keyword final come up in the CAD requirement? Is that
Not really. It's mentioned, I think, once. Let me pull up the actual CD again here, but it is not something that you have to really cover. It's like because we no longer have inheritance, and like so it's on class variables and methods, so you can create a static final variable for something that is like, oh, here's the like for making a constant, but it's not a thing really. Like it's not a big concept in the exam or the course. So it's like if you're going to make a constant, you have to have the keyword final on it, and it should be talking about naming conventions named in all caps snake case. But that's that's the extent. It's like because most like the only finals that I ever use in a Java program are math.py. It's like, oh, you need to reference pi and it's not just 3.14 math.py. But it's like,
Cody, are abstract classes covered now?
No inheritance at all.
Okay.
Abstract classes have been out since 2014, I think.
Hmm.
They've been out for a bit. I still teach them, but they're not in the course anymore.
Okay.
I still teach interfaces too, but yeah, no longer part of the content.
And interfaces are also not part of it anymore, correct?
Correct.
Okay.
Yeah. Outside of scope, I still teach them because they work really well with what I teach, but you don't have to worry about them anymore. All right. Good break. So we've been working with the Unit 3 concept of creating objects and what goes on in the process to do that, how to actually build an object with that. Again, with the I would spiral in Unit 1, Unit 2 stuff. Oh, we're going to do logic in here. We're going to work with make check to see if this monster's eye count is greater than the other monster's eye count for using of Unit 2. We're going to assign variables with that to practicing Unit 1 stuff. So again, you can go back and spiral back to those concepts from Unit 1 and 2 that we just worked with. Of course, we'd make the two string have spaces between it rather than having it just all squished together. That'd be one of those little, oh, we didn't put a space in there for concatenation. We should either do a \t, \n, or an extra space when we concatenate those values. Realizing that those are the pieces that we go back to that process again. But Unit 3 this is why I do Unit 3 all over the place, is because you can introduce those concepts with it. My controller is where all my work happens. And so that's where all my assignment statements and my logic stuff would happen. And my control, where's the window? Sorry, I have to find out where the window pops up to person to the canvas, or not canvas, to zoom. But it's making this as convenient as possible for doing all those different pieces. Like, oh, here's where this stuff is, here's where that stuff is. Making it be just basically as quick as possible for those pieces for that. Doing so to make life like, oh, here's where this kind of job lies. And so we already saw that idea of decomposition when we were working with the IO controller. We put that over here because it's like, oh, reading from a file doesn't belong to my regular part of my program. And when I need to read from a file again, I want to copy just that piece of code and rewrite just that part. I want to write all the stuff that goes with it. And by having its own separate file, it's like, oh, excuse me, this logic lives over here. It's not something that's always right here in my main project. It's in this special little section over here. And so that's why I did the IO controller like that. So quick review of what we had just been working with for units 2, 3, and IO. Questions, comments, clarification points, anything like that? Thumbs up? Okay, fantastic. Thank you. All right, so our next thing that we're going to talk about is Unit 4, data structures. I love data structures. I'm not being obsequious. I am being completely serious. There is no sarcasm attached to this. I start with array list first. Array list works like more things in Java than arrays do. And especially how not unit 3, Q3 is going to be array list specific. I think it makes sense to work with that as well. I've been working with array list first for more than 20 years. I honestly don't know how long it's been. I think it was only my first 2 years of teaching Java that I was working with arrays first. I've been working with array list first for quite a bit. But array lists are a dynamic data structure, and they do great things. I think they're really nice. They do require us to use an import statement. Oh, okay, no big deal. That's easy to add. But array lists match what students see on a regular basis already. They're used to working with lists of things that can grow and shrink as necessary. Shopping lists, chore lists, things to do for the day. This is something students have been doing, like, oh, and they can check them off. And it's those things shrink down when they're done with them. This is a concept students have prior knowledge on. We're just going to do some formalization of that to work with it in a code type fashion. And so we're going to make an array list of monsters. Because, hey, we can. So we're going to go over here in our monster project. Step 1, of course, is to add the import statement for it. import java.util.ArrayList. So we have our array list right here. Now, array lists can exist as data members or as as local variables. You got a choice as how you want to do that. We'll talk more about that as we go through. I'm going to make a data member version for this first demo. So I'll make a private array list. And then I use gang signs, angle brackets, to say what's going to be inside that array list. In this case, it's going to be marshmallow monsters. And I'm really boring. I describe what's inside the list as part of the variable name. It's a monster list. Now, because that's a data member, I need to initialize it in which piece of code? Whose job is it to initialize data?
Constructor.
The constructor, yes, that's its job. So let's initialize it right there. This dot monster list, capital L, equals new array list of angle bracket marshmallow monster. Now, there is the new-ish diamond operator, which is the empty open and close gang signs. I don't use that. I explicitly call out what's on the left-hand declaration matches the right-hand initialization side. So I'm very big on filling out the gang signs. You can use the diamond operator, open and close, but again, I write code for myself to read in the future. I want to know what's stored inside that structure, so I explicitly call out with that second set of angle brackets what the data type that's in that structure is. It'll compile just fine with empty angle brackets, but we write code to be better, and so I spell it out. All right, how many things are in my monster list right now? Zero. Now, can I make my list be a certain size to start? Nope.
Yes.
I can use there's a constructor will take a collection type and use this default iterator to put them all in. But if I just say 10 on those parens right there, it doesn't actually say it's a 10 list big or a 40 list big if I put 40 right here. All that does is behind the scenes, it says allocate some memory for something. It's still zero big. So when you create a list, it doesn't put anything in it to start. If you pass it a number, it doesn't actually give you that much space to start. It just says behind myself, I'm allocating some memory because I think I'll have that many in there, but I'm not putting anything in it yet.
So what's the value of that?
That is if you put a parameter, the int parameter to it, it's saying to allocate enough memory behind the scenes for that many things. That's all it does. It is the most useless constructor on the planet.
It doesn't make a lot of sense to me. Okay.
Yeah, no, there's no good reason for it anymore. It's because the way array list and most of the collections type works is they allocate memory behind the scenes already, and when they run out of room, they double in size of memory allocation behind the scenes. So rather than telling it to start with some number to start for memory allocation, no, just put them in. It works better. And we'll talk about that actually in two shakes with this as well. So now I have two monsters, and if I want to have two monsters, two variables is great, but what if I want 40 monsters? I do not want to have 40 data members in my thing or 40 local variables in my method. If I need 40 monsters, I'm going to use a list or an array and a loop to generate them. So let's do that. So I'm going to have a private void make lots of monsters. Zoop, zoop. I'm going to call it after work with monsters. Make lots of monsters. And again, I do lots of tiny little methods so I can practice what I'm working with. And I can look at just pieces of code. And if I start getting, my code starts getting big, oh, I might want to actually pull this into a different pile of code, make a new method. Again, that's that idea of that refactoring, or again, how I do unit 3 early on, where excuse me, please, each small pile of code does one thing well, and I can identify it and go back and reflect on it, write about it, use it again later. So make lots of monsters. I want to go ahead, I want to make a lot of monsters, so I'll make a for loop. For int index. Ooh, I can do spot. Spot's a good name for this too. Equals 0. Spot is less than the number I'm starting with. I said 40. And spot plus plus. Okay, so that gives me 40 things that I'm going to count 0 to 39. Wonderful stuff. And I'm going to go ahead and put a new monster in there. So I can say marshmallow monster temp equals new marshmallow monster. And monster list dot add temp. Boom. I now have 40 monsters I can work with. And rather than having 40 plus lines of code, I have 4.
Can I ask a quick question?
Always.
So this is building the boring monster, correct?
Correct. Yes.
And I could create an input file where each line has all of the values for the various characteristics of the monster if I want to build custom monsters as a extension,
Uh-huh.
for
Uh-huh.
example.
Uh-huh.
Okay.
And that's part of tomorrow's assignment.
Sorry.
No, 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 that's cool. No, it's like, yeah, you are going exactly where we want to lead to. So that's perfect. Yeah. Because you can, and because using Excel to generate a whole bunch of data and just and you can like auto randomize values using the random method inside Excel or Sheets. So you can get like, oh, here's a random eye count, random leg count, whatever, and just do the copy feature down, and then just type in or paste a bunch of names in there, like or monster one, and have it just do the drag down where it names the monster one, two, three, four, five. Totally doable. Yes, take advantage of tools. Thumbs up. Thumbs up. Yes. We'll talk about that though in a bit, but yeah. So this creates a whole bunch of just boring monsters. And then I could also use the magic of another loop, and I can now use the for each loop, the enchanted loop, as my student called it in one of their notes. So I love that, the enhanced for loop. And so I can do for, and I can do marshmallow monster, current, colon, monster list. And the enhanced for loop, or the for each loop, allows me to process every single one inside there. And so I can go through and do all of them. And so I have in my marshmallowmonster.java, I have a setter for leg count. I can make it so they all have a random number of legs. So I'm going to say int random leg equals new, or equals new, equals int parens, and then math.random times, and then the scalar will have, what's a good number of max legs? 30? Sure, 30. And current dot set leg count random leg. So I'm going to go through and for all my monsters in my boring monster list, I'm now giving them a random leg amount. And so this using math.random is a skill your students need to know. It has been a tested question on the free response in some form every year for like 7 years. I have a strange feeling that next year it's going to also work with math.random again. And the proper use of math.random for both int and double is a skill your students should definitely practice. This is the demo of how to work with it as a scalar for an int type, giving a number from 1 up to but not include, or 0 up to but not including the scalar value of 30. But if you want between 1 to 6, for say, for example, doing a die roll, lots of great ways to make that happen. And so I can go through and I can make lots of monsters. I can process those monsters. I can make a algorithm to go through and count all the legs. So int total leg equals 0. And then I can use a while loop and I can process that list as well. Because you can do a list with a while loop for that. Great thing to do. So while, um, let's see, I have a, actually while loop is really not the best choice for that. So let's use a for loop. We'll go backwards though. So for parens int index equals, and we'll say the size minus one. So monster list dot size minus one. Index is greater than or equal to 0. Index minus minus. And reminding students that they definitely have to be used to processing lists in different directions. And we're going to go through and we're going to say that monster, current monster equals, not monster, equals monster list dot get, passing it the index and total legs plus equals current monster dot get leg count. I didn't write the legs for that. Oops. Public int get leg count. This is why it's important to actually do this the first time. Return this dot leg count, and this is when I'll have students like they forgot to do this. Why didn't why isn't it working? Oh, I didn't write all my getters. Oops. This is why you actually want to do it, because then you come back to the assignment later, it's like, oh, I need to actually get those leg counts. And so it's like a reminder, like, oh, why isn't that working? Well, I don't have that method. Why don't you have that method? You have to go back and do it. And so now I can report back to the user the total leg count, system.out.println, the total monster leg R plus total legs. Boom. Run my code, happiness and joy. There's 628 legs this time. Run it again, 537, 552, 489, 512, 525. I can run this code 800 times and find out what the max random leg count is. And I could put that inside a loop as well to practice with that. Again, working with a list and those algorithms you have to do for data in a list, practice right here. And so unit 3 directly goes straight into unit 4. Because you can then use it to actually count pieces and work with things inside an array list of object. But marshmallow monsters are a quick way to actually play with that. Not the only way, of course. And so we made a quick array list right here. We put some monsters in that list. I do an exercise with my students for another algorithm. We have to take things out of a list. When I'm taking things out of a list, I have all the students come to the front of the room, line up. I don't care what your order is, but put you up, and I'll find something that at least 2 peeps have in common. Preferably more than 2, but at least 2. And I make sure that they are together. I hit move really quick. It's like so that they're together. I'll move a couple other people as well to make sure it's not, they don't realize what the Y is on that. And it's like, oh, I go to the front of the list and I'm like, okay, you have a jacket on. You can say, you don't have a jacket on, get out. You don't have a jacket on, get out. And I go through and because I'm starting at the front, when I remove someone from the list, what happens to the rest of the list? Oh, it squishes down. And so because it squishes down, I will skip over values. And so I have people on the list who aren't wearing jackets, but I should only have people with jackets in the list or people who don't have jackets in the list. But I skip people because I didn't properly address that issue in my algorithm. And it's like, oh, if you're removing things, never start at the front because otherwise you have to modify your index parameter after remove is successful. Instead, when you're removing, always start at the end. Go backwards through the list because the shrinking down, you've already looked at the people that will be moving. And so it doesn't affect the list structure in the past. And so removal should always start from the end. That way you don't have to remodify your index parameter or your index variable, excuse me. Parameter is the wrong word. I don't know why I said it. But that's a great way to like, oh, here's how you have to think about what you're doing. And when you add someone to the middle of the list, what happens to the people who were before them? Oh, nothing. What happens to people after them? Oh, they shifted down. And so it's why you have to actually keep track of how things are happening in the structure of the list, where placement is, and why placement matters in a list. And it's like, oh, this is what we're doing. And so it's like, oh, here's how this works. And I do that with ridiculous amounts of times in front of the class. I'll use just the row of students in their chairs, move through your chairs, rearrange yourselves on that list. It's like you can take your chairs aren't physically attached to the desk, so you can actually move that around. If they're physically attached to the desk, obviously that doesn't work. But just ways to actually physically have the kids get up, get out, and around really helps them work with the concept of a list and the structure that's attached to it.
Hey,
Talking
Cody,
about, yes.
about how long do you spend on like the monster activity in your instruction? Like how many hours would you say it takes for your kids to do this?
Just the first part of it, like creating the monsters, writing the code, and doing the first bit of stuff, that's one class session. So I guess that's 2 hours for me.
Okay.
And then I'll come back to it to introduce array lists for other because like, oh, we did our monster project. We're going to come back and work with it again to do the array list part of it. That's not the next day, but I'll come back to it when to practice working with array list again.
Okay.
So that would be, it's like the array list part would be a completely separate part of the project, not even the next day. It'd just be, let's go back and let's use, because I'll have a lecture about working with array lists. I'll have them read the API, which I'm going to have you do in a minute. And they've done some other exploration of that. And they have, of course, the stuff that's in the AP Classroom that's on it as well. But then we come back and like, let's use it in an existing project. So we will
Okay.
create a temporary array list. We'll work with strings and put strings in a list and go from there. But then we'll come back and work with the array list with monsters. So it's like that way. It's I'm using an existing project to add to detailed knowledge of a new topic. And so that way they come back to one of their projects they've already worked on that's already done, and then we're going to make it more done. Yeah, good question. Thank you. So now what I want you to do is one of the things that I have my students do as well. I want you to go look at what ArrayList is in Java. And so one of the tools that I have the students should work with and get comfortable with is the APIs. It's mentioned back in Unit 1. It's like Unit 1.10 or 1.11. I don't remember which one. It's in the double digit section. But APIs are a critical piece of actual modern software. So everybody Google Java ArrayList API. And I want you to find something you think is interesting, something you didn't know, hopefully, or something you think is important. And have you come back and you're share it with the group. Okay, who has found something they didn't know about ArrayList in the ArrayList API?
I'm noticing there's a lot of talk about synchronization.
Okay.
Tells me that if you have an application that shares an array across multiple instances of something, that you have to be mindful of how of the state of the collection as each of the instances is using it, which makes sense. I just I don't often think of Java in terms of threads, as odd as that may sound, but that
Yeah.
was something I found interesting.
Yeah. That is something students usually ask what that will mean and stuff. Why, like, what is this synchronization? What does threading mean? And like I'll talk about like what like how many pro if you're using multi-processor programming. So and what that means to that. And so it's like in the APCSA class, there's no requirement whatsoever to even address threads. I do talk about threads for purposes of doing some small counting type things, and how it's like if you're working with things that are talking to multiple processors, those have to be spun off on threads and then collated back in. And we'll hit that more in our second semester course in my at my school. Um, but we don't have to actually worry about explaining that at all to students, thankfully, because there is no multi-threading component to CSA. So they don't have to worry about that concept at all. But it's like that's what I tell them. It's like if you're trying to write code for multiple processors to be handled in a specifically multi-threaded way, there are things you have to do. And I do have a couple of students every year who try and actually work on that and figure it out. And generally it ends in frustration. And it's like, that's okay. Frustration is actually good for this. This is something that's not a simple thing to look at. And we talk about what happens when we're working with threads. I may do a demo later on. It's like, oh, these things, it came out in this order this time. And then I spun the threads off again. It came out in this order. I can't control the execution of these things. And realizing like, oh, I have to make sure I can handle that. And what happens when we have threads that spawn off and how to work for that. And I'll do a little, I have a little side lecture on semaphores and how to work with that. But like that's something that it's like for class we don't have to cover, but it's like I'll have like a little side lecture, like, hey, if you want to learn more about this, here's where we go. But yeah, good one. Someone else.
I found last index of that was interesting.
Hmm. Last index of is a nice one. There's a
Because
couple new.
when I teach it, I teach the kids if they're looking for the last occurrence of something to start at the end and find
Mhm.
the first one and then bomb out.
Yep. Yeah, and so there's a couple new methods that Java added to the collections type. So it's the get first, get last, and then the last index of and the first index of. These are some great helper methods that can do some stuff that Java, I think it's Java 21 where those were added in. Like, oh, these are things that we've actually written, like there have been questions on the CS exam that ask them to find the last one. And now there's, oh, here's a method that just does that for you. And it's like, so what is the logic for it? It's like, oh, here's something you like. So we're writing code that actually gets, there's a use for that. Like, oh, here's how that happens.
Meaning you don't know the length of it and you want to find the last index. Is that what that
Exactly.
is?
Like, where's the last time I find this value in the entire structure?
Oh, I see.
Yep.
The value inside the. Okay. Well, anyway, I was going to mention clone. I hadn't seen that before.
Yep. Clone is a great one for a shallow copy of a value. And you can be like, oh, I want to work with this, just a shallow copy of the stuff, not all the new objects, but just here's another a shallow copy to it. It's a great one.
Yeah. So what's the meaning of shallow?
So they're pointing to the same objects on the heap versus new allocated pieces of memory for it. So it'd be the same, in this case, the same monsters themselves. So it wouldn't be brand new monsters, a new list of 40. It's a new array list that has references to those same objects.
Okay. Thank you.
That's a good one. Dot clear is a wonderful one. I want to wipe out my array list. I'm done, but I don't want to throw it away. I just want to wipe out all the contents. I use that one a lot. What does dot add give us with one parameter?
it adds another element to the end of the list.
But what does it give us back? What's its return value?
And you said how many
True,
parameters?
false.
One, it's not
Ooh.
false.
No,
It is only true.
Interesting.
only true.
It can't return false. That's why you don't test against it. So the .add method always returns true.
What about add all?
Add all is I want to put all the contents of some other structure into this structure. That's a great one. I like that one. That was really nice for building like ginormous lists. I've used that one on database-based assignments and queries. Like, here's a list of stuff. I want to add all of these things into another list, then add that giant list into yet another list. Yeah, add all is a great one.
Does it also only return true?
Add all is a Boolean. Let's see. So Boolean add all returns true if it changed the list as a result of the call. So if add all did not change the list, then that says it could potentially return false. And so it's returning add all from class abstract collection. So we'll go to the add all from abstract collection, and it returns true if the collection changed and it's specified by interface. So add all on that. And yeah, if it ever changes, it should return true, which means that
So basically, it means it returns true if it works.
yeah.
Something like that. Okay.
So if you change the list at all, it works. Yeah, and so it shouldn't return false. But the add method will never return false. It only returns true. If for some reason it's not going to return true, it will throw an exception instead.
If I give an empty list or whatever to add to another list using add all, is that going to return false?
If you threw an empty list, since that would not modify it, that should return false, yes. But the add method will only return true, as specified by collections.add. And the exception thrown is, where's the exception that it throws? The illegal state exception or unsupported operation exception. But yeah, if it can't return true, it throws an exception. Like it will always return true, basically.
What does the to-array method do?
Okay, the to-array method. Let's pull that one up here. I'm just going back to the list so I can find it. Says, okay, so to-array. So that takes the iterator of the array list, and it uses the iterator to find out how big that array list is and populates that with an array of that type of each value in order using the default iterator to an array of that object. So it'd be, if you have a array list of monster objects, it would be turned into an array of object. Specifically, you could make it to cast that down to then an array of monster object. So if I were to pull that up right here, I could do that right here. So I could say a marshmallow monster array stuff equals, and then we'll cast that down as a marshmallow monster array of, and then the monster list dot to array parens semicolon. Yep, there we go. So I would take the contents of that and immediately transfer it to an array. That is something you could do. I actually have students, like that's a way it will automatically depend. I have students actually process an array list and turn it into an array and vice versa. Because like, oh, I need you to make sure you extract all the values of this and put them into an array, not usually the whole size. Like I want you to put like say 50 of them in. That's like, okay, I'm gonna go through and put these ones in. Or put the ones only who have a value greater than this. So figure out what the count of ones that have legs more than 10, and then figure out the count of that, and then make an array that's that big that have the legs more than 10, and then add those ones that match that stat to the array of that type. And so I'll add those to the array, add the appropriate index. And that way they're working with processing things by different sizes, incrementing the correct variable, and going from there. Yep. Yeah, two arrays not on the list of ones they have to have. There's only, what, 7 methods you have to know for an array list, right? 5. Add, add with 2 parameters, size, get, set, and remove. Dot set gives you back the thing that was there. Very helpful to remember. Also very helpful to remind students, you cannot insert data with dot set. So if there's not a value at that index, if you try to call dot set, you will crash your app. Dot set can only operate on existing values, so size -1 greater than or equal to 0. That is one that students have mistakenly used many a time. Any other questions about the Java array list data structure, data type?
You said you teach array list first before. Is there a reason for that?
Because array lists work like all Java objects. They have methods. They're dynamic. Especially, I start with array list of string, and it's like, oh, I'm going to get user input. I'm going to collect all the input until I tell it to stop, and then it stops. So it's like, oh, that way it's like I collect all the answers from them that they've worked with, and I can print those all back out. Versus an array, I can only collect 10 things, or I collect 100 things, and it will keep growing until I'm done with it. And once they type in the word that will stop that loop then stops, and then I have an array list I can then process and work with that. And because string is a really easy object to work with, and yeah, and array lists have methods. Arrays, on the other hand, are hipster. They don't have methods. They are special. They don't work like anything else. They only have they use square brackets. They don't have parens anywhere. They are not part of your thing. I used to call this hipster day when I talk about arrays because like they are not like anything else that code. They think they're special.
They have the same concept in Python, right? Those arrays or lists in Python.
Yeah, so yeah, in Python they don't have actually a array. They have just the list type exactly. And so I teach the dynamic structure that works more like everything else in Java with methods and modifications versus square brackets only exist on arrays. And so it's like, oh, these are special. We're going to treat them special. And we're going to see how they work differently from everything else after working with array lists already and all our other objects we've made. Yep, yep, yep. How have you used array lists in your classes for those of you who have already taught this course? What's something you've used with array lists for your class?
I think it's a pretty common project, but like airline seats, array list of airline seats.
Okay. Airline seats are a great one. Reservations. Yep. Each reservation has a person, has a seat name, might have an amount paid, all sorts of stuff you could put inside that object that's attached to it. What's a limitation with array list? What can't I use an array list for?
Primitives, but you can wrap them. So
I have primitives, but I can wrap them, and I have the magic power of auto boxing and auto unboxing. And so that's something that I will work with students on as well. So I can do that here with you really quick too. So I can't make an array list of lowercase I int. But if I want to collect a whole bunch of numbers for some reason, so private void work with wrappers. And we're not talking people with MC in their name. So I'm going to make a local array list of capital I integer numbers equals new array list of capital I integer. And so I have my list of integers that I have. And we have to, so an integer is a way that we can deal with primitives with collection types. Because collection types can only hold objects. Because that angle bracket right there, that gang sign, only works with objects themselves. You can't put a primitive into the angle bracket. If I try and put int inside here, boom, I get a nice little error message. Syntax error, insert dimensions to complete reference type. Because it's like, oh, that's not an object. You have to put a object only in there. And so I can only put objects in there, not primitives. And so the integer type with a capital I, double with a capital D, and Boolean with a capital B are the wrapper classes for those Java primitives we have to work with. But because of autoboxing, I can do this. I can just put the primitive literal 3 in there. I can also put sample in, which is clearly an int variable. It automatically puts that into an integer box, a wrapper class, wraps it up inside the box, and then puts it in the list automatically. I can also auto unbox it. Int result equals numbers dot get 0. So I can take out that capital I integer and immediately shove it into an int variable. I can even use the magic power of a for each loop, and with an int on that, for int number colon numbers, and system.out.println number. And so I can use that to extract all the contents of that array list of capital I integer by printing them out as an int. And Java doesn't care about it at all. I don't spend a lot of time with wrapper classes. My ints belong to objects because they're like, oh, it's a leg count. It's a score on a test. It is a grade level. It is some other thing that's a part of an object type. I don't really use wrapper classes other than small demos like this. But I do demo it at least once. Other questions, comments about the array list type? Okay, what I want you to do now, I want you to go to the CED. I want you to find something about Unit 4 array list that you think is important or critical to teach. Yes, it's in the CD, it's important. What is capital I important? So go to the CED, find something you have to teach about array list that you think is capital I important or critical. So let's take 5 minutes. It's 3:33. Let's come back at 3:38. Find something that is critical that you think on that list. Like, oh, this is not just important. This is like, oh, I need to share this. All right. Do, 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 do. Excuse me, please. Okay. Set it back. All right, still have some time. Okay, one more minute of finding something in the CED Unit 4 about array list that you think is important or capital critical to talk about things with your mammals. I mean, yes, I know they're all important. That's why it's the big important. Okay, Kai, thank you so much. We've got one on there in the chat from Kai on the importance ability of traversing backwards or modifying the index when removing data from the list?
Yeah, I would second that.
Okay.
And the out of bounds errors that happen when you have that.
Oh, and if you're modifying the list, that you can cause out of bounds exceptions. Oh, most definitely. Yes, if you modify the size of the list inside that, making sure you then check before accessing again, double thumbs up. Yes. Someone else, what's another critical or important thing when working with array list?
I think the knowing the different ways of how to truly reverse the elements in an array list is pretty important. I've
Mhm.
had students who will just print it out backwards, and I'm like, well, you haven't reversed it, you just printed it backwards.
Mhm.
But knowing that you can make a temporary array list and you know grab the elements backwards from the original and then reassigning at the end, or using the a for loop where you cut it in half and you kind of switch the elements that way, so that there's different ways of truly reversing
Okay.
the arrays.
Thank you, Jess. Fantastic. Array explicitly called out 4.5.a.1. Yes, the algorithms you have to know. Fantastic right there as well. Okay. Another way to work with array lists, carabiners. Again, the magic of going to Amazon or Oriental Trading Company or it's just that these are tiny little carabiners and you have each student get one. It's like, oh, you have to make a list and you want to remove from the list. I'm like, oh, I'm going to put this one in here. I'm going to take that one out of the list. And so the steps that I have to do to put that one out, I'm going to take that one out. So I have to move this one right here. And I have to reconnect it right back up. And here's my new list of stuff. And I can have them like, oh, I've now got this. I had 3 students put together to put this, or 4 students put together to put this. And it's like I still have to keep those ones in that order to remove that one. And in the process of looping over the list, you have to pick it up and touch each thing and process through it, and or like say what color it is. And so it's just a little physical manipulative, cheap, not too expensive, and very easy to play with in the classroom. And you can give them to the mammals, or you can just like this is a quick demo thing, put them back in the bottle in the bucket when we're done. And so you can buy a giant bag of them for relatively cheap. Like I think the bag was $10 for a couple hundred. They're tiny. And so if a couple disappear, I don't worry. But yeah. But using manipulatives with your mammals is a wonderful way to help them gain that connection. It's like, oh, this thing goes with that. And then you have your debug ducks. You can also work and put the ducks in a list, move the ducks around, use your algorithm to shuffle the ducks. Use your algorithm to get only the ducks that have green spiky hair and put those and take those ones out. And so using the debug ducks that you have in your classroom with the students, have them work with their small groups, their rows, their tables, whatever, and using their ducks as the objects of the list and process those algorithms on not paper, but physical, like, oh, here's this thing, process that, use the array list algorithms to do that. And they have a physical thing to do, then they can go back and write about it, write the code that would go along with that, and go from there. And because it's small code, they don't have to even write the full object for the duck. They can, this is something you could just put on your little whiteboard and do that as an exit ticket to go out of that. Make sense? I got a thumbs up. Fantastic. That's what I'm going for. Okay. So with Unit 4, we have lots of stuff to cover. We also have arrays to cover. Arrays are their own separate thing. Now, when I'm working with an array, I have a whole different set. It's the Java type that doesn't have a keyword. Instead of a keyword, what do I have for an array?
Are you talking about just like the index of it? The index
Nope.
of elements?
There's a keyword for array, but it's not really a keyword.
Is
We
it
have
like the square brackets?
the square brackets.
Oh, that's what you're talking about. Okay.
But we've been working with square brackets since day one. So you mean to say that I've been learning arrays since day one? No, but you've been having an array as a parameter right here. Oh, and this is where we talk about the console. And it's like, oh, arrays, console programs. It used to be you'd have to not double click on a program, you'd type the name of the program and then any flags or parameters that would be sent to that program. And if you have access to the command line at your school, this is a great way to show how the terminal uses an array of parameters to then work with that. And it's like, oh, I want to do ls-a. I want to list all the things that are hidden. I want to do a directory, but I want to have the directory look like this, blah, blah, blah. And you can use the dir command. You can edit and then a file. And so you can pop up or gedit and you can open a text file with that. And it's like, oh, that's what we're doing. If you don't have access to the command line, that's like, but that's what that's doing. It's like, oh, I'm telling it to run the program with these parameters that were sent to it when I run that program. And so your students who have Linux experience or background, like, oh, that's what that's doing. And so your Linux mammals will have like, oh, that's where that stuff's coming from. Because I'm like, oh, these are the parameters that are sent to that program when you call it from the command line. Now you can actually use those inside Eclipse. You can actually send the parameters to that. That's where that run configuration that Torin ran into earlier. I can go into that and I can actually send parameters to my main method if I really, really want to inside Eclipse. But we don't because like at the schools that I've worked in my district, teachers can't get to the command line at all. They can't run cmd.exe on their Windows machines. That's blocked. If they are a Mac user at the elementary schools who have Macs, they can't go to terminal. That's not available for the teacher login. Definitely not available on the student login. And so our students, there's a really good chance that they've never seen the command line. And you go to many businesses and you don't have access to the command line if you're not a developer. It's quite common for that to be turned off at the main IT level. It's like, no, can't do that. Most programs that human users work with don't talk to the command line. And the idea of setting flags to a program and saying supplying information from the command line execution point isn't a thing that we do, but that's where that comes into play. It's like, oh, that's what that's for. But we can work with arrays easily inside Java. We just have to learn that there's some special stuff for that. And so arrays are a little bit different. What are some of the things that you know that are different about arrays? Either put it in chat, say it aloud. This is a nice open source for people to like, hey, you can even basically shout this out. Can't say change size. Size is fixed. Exactly.
You have rows and columns.
A two-dimensional array can be referenced with row and column. It can be. Dot length with no parens. Yes. So if it doesn't have parens, what kind of thing is it then? If there's no parens on it,
A field?
it's a field or data member, and what visibility is it?
You mean whether it's primitive or
Well,
is that
dot length. What kind of um, what kind of visibility is dot length? If I can
Public?
run it, it's got to be public, but it's a data member. What? So it's a non-changing public data member. So what keyword gets attached to that?
Attribute.
So if it can't be changed, it would have there's someone asked a question about this a little while ago.
Final.
Final. So, and the code that writes Java, the declaration code that makes the array type that we don't get access to, the length is a final public int. Oh. And because it's unchanged, that's why it's dot length. And that's the same reason why strings use dot length, because their length is immutable. And if you read the core Java textbook that talks about the whys of the Java language, it mentions that somewhere on like page 200 something. I don't remember where it is. It's in the first volume of core Java, and it's not in the first half of the book. But that's all I remember. It's not critical information. It's just stuff that's stuck in my head. Okay, arrays can only store elements of the same data type. Yes. So this is where it's not like a JavaScript. You can't just randomly throw things together. It can only hold strings, or it can only hold int, or it can only hold Boolean, or it can only hold marshmallow monster, or it can only hold object. It can only hold string. So you can't mix and match on the data structure attached to it. Very good. Other pieces of information about the array data type that is a data structure. Is it an object? Yes. Does it have methods? Other than what it inherits from java.object? No. It has no methods of its own. It can't do anything. It only holds values. You could totally call it an attribute or field. That is totally correct. I say data member to everything just because that's the word I love, but it is an attribute. It is a field. It is a property. These are all valid descriptor verbs for this, or descriptor words. Those aren't verbs. But yeah, totally not incorrect. Yeah, the great thing about Java is they don't have an official thing for almost anything. We have it as method, but you've got functions and procedures. If you're going strictly for the term function, a function has to return something, and a procedure doesn't. So a method can be either a function or a procedure. I say method because it works for both, but especially if you're a math mammal, it's like, no, you can't call that a function because it doesn't do anything. But multiple textbooks refer to the any method as a function. But strictly math speaking, functions have to return something, but it does return something. It returns void, it returns nothing because that's its return type is void. And there is a void type behind the scenes that you don't have to talk about. But that's another thing to worry about later. That's like Java 3, not Java ACS, ABCS. Okay, other things about array before we go into some more work with it. This is one of those spots where, again, coding bat is your friend. Because coding bat has stuff that we can practice really quickly and demo those concepts. Like, oh, here's some stuff. And again, it doesn't matter the answers are already there. That's not the point. The point is it's a tool we can use. And so I'm going to go to array 1. And we're going to do sum 3. And so I want everyone this time to do sum 3 on your own. And then we're going to see the different ways that we did sum 3. She's still at work. Hey, thank you for getting that posted in the chat. Who has a solution that works for all the things that are given to them from codingbat.com? Okay, David, a different solution. Fantastic. Thank you. Alex has the same one. Okay, we have a standard for loop to go through and process them that way. Okay, fantastic. Multiple solutions to solve this. Anybody use a while loop to do it? No, let's do that right here. I'll do that one with you. Okay, so Henriksen, speaking to myself in the third person, I'm very big on making variables always, just because that way it always compiles. Even if I write code that doesn't work, I can have code to start off with. It's good. So I have int sum equals, and then sum starts at 0 because that's the minimum value, and then return sum. So again, if I start off just with that and I hit go, I automatically have compilable code that's wrong. Hooray! Okay, making a while loop. I need to have a variable that's not sum because the sum could be 0. That could be a valid test. So I don't want to use sum as my variable. So I'd have a variable for that. And so I have a int length equals nums dot length. Okay, a variable I can reference and talk to. While length is greater than 0. And then because it's a while loop, the last thing I need to do is modify my tested variable. Length minus minus, semicolon. Sum plus equals. And then nums dot length minus 1. If I run this, I have an answer. Hooray! And I don't have to worry about going out of bounds because my length minus 1 right here is always guaranteed to be invalid. I subtract it after I go through, and so when I get to 1, it goes to get me spot 0, the last spot in the list. Length is now -1. Length that's no longer, or length is no longer going to fix that. So boom, I can get past that. So I have when I get to 1, it goes to then 0. 0 is not greater than 0, and so I don't go in there and I get that. I get my sum right there. Hooray, hooray! We have different values of solutions right here. Wonderful job, my peeps. Great job. So there's different ways to actually grab that information and process it. And so the idea that there's different solutions for this, and you can do this in different ways, is a learning experience for your mammals. Okay. I want you to do two more coding bats in the array one section.
Should we do any specific ones or whichever ones we like?
Just pick ones that sound like they'd be cool, or click through like no, 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 yes. No, I want you to just to pick a couple because all of array one are easy. So they're all good practice. And they teach different processes on each of them. So it's like, oh, here's a good thing to practice this. Here's a good thing to practice that. And just pick two that you want to try.
Does chance randomize it?
I think so. Yep.
Oh, that's fun. I'm gonna do that.
Yep. Yep, he's using the API to then get a value from the array one group with some parameter specified by the it's set to chance. Okay, who remembered or figured out something that they knew about Java? Like a deeper understanding, or like, oh yeah, or that. Who's like, yeah, I got this. I'm comfortable. That look did not seem like it's like I'm comfortable. That was like a, oh, excuse me, please.
I had a lot of fun with the no two or three. Um, I believe that's what it was called. I closed out of it. Well, that's helpful. But right, no two, three
No
in
two,
the
three.
yeah, in the
Yep.
first column. And
Yep.
I used a for loop.
Hmm.
So that was fun because I was like, oh, because my kids really in principals like really struggled with for loops this year.
Hmm.
Um, and so I was like, oh, this is a great way to even just to use this in that class too.
Yeah. And it's like if you're working, and it's like if you're working with Java, CodingBat's great. Python, you can also use CodingBat for that.
Right.
Just practice accessing things in the structure. And it doesn't have to
Yes.
be a big thing. It's just a quick little thing. It's like, oh, is this thing? And then the compound Boolean logical expression. Like here's the check and check. Here's the check check. And here's the check and then interior check. So compound expression, nested expression, sequential expression, how they're be done equivalently. And it's the same logic just spread out different ways. Yeah, that is a fantastic one. That's one of the reasons why I like doing this. It's like here, let's another way to let's do another solve for us. We already solved this once. What's another way to do it? And just delete my code that I just had, where I'll have my code that we originally had pasted on a different document. Okay, here's the solution we know works. Let's write this another way.
Yeah, I anticipate that being really fun and really useful for students just to see all the different ways you could think about it.
Yeah, I've been that's one of the things I really like about that. So coding bats, one of the things I'll do specifically, especially like at the end of the day with them, it's like you and your elbow partner get together and solve a coding bat. If you don't solve it, explain why you couldn't solve it. Like this is what's not working. Explain like what test didn't pass and explain that. That's your exit ticket to get out. And just put that in your notes or show me what you're not what's not working, and you can come back and it's like I've got to figure this out, and they'll share that with each other. It's like, yeah, this is how we can solve it. It's like it's not homework. It's just right now. If you want to come back to it, that's great, but it is explicitly not homework. And then if they obsess about it, that's their thing, but it's not homework. It's not expected to be homework. I'm not trying to guilt them into solve it. No, it's I'm very big on not using shame and guilt with the class. So, okay, arrays. We're not done with these. We're not done with array list, but we've introduced them as concepts. And there's a bunch of stuff to go in that inside the CED. Lots of topics, lots of algorithms, lots of practice. Integrating arrays into your project all over the place. Small questions, test questions, quizzes. And then there's this amazing thing, AP Classroom. You don't have to make assignments. Just go to AP Classroom, click assign. Done. AP Classroom, select all the array questions. Done. AP Classroom, do a free response question and don't grade it. Just have them try it out. It's not the grading is not the point. It's the have them practice with it and then talk about the answer. Even if you don't give them the answer, talk about how to get to the answer. And they can let that process in the back of their head as long as they need it to. It doesn't have to be done right now. It doesn't have to be completed right now, but it does have to be addressed. And I can just sit there and process for a bit, process for a bit, process for a bit. Oh, I thought about that. Great. Good. And And that's one of those things where it's like you have the students take the time to go through that. Let them give them time to think. Let them work on things. Even if you're in a rush, pause, think, wait, reflect, and come back. Because yeah.
I wanted to ask a question, a clarification about the use of some of the questions on AP Classrooms, the ones that are designated secure, I
Uh-huh.
guess.
Yes.
So is it so you can assign it to them as a test that they take online on AP Classroom, right?
Mhm.
So you
Yep.
can, but you can't give it to them as like an assignment.
Yeah. So if I go to all questions and I go to security and I want teacher use only,
Yeah.
and we'll go for course content. We want just on unit 4. We want array traversals. Boom. Okay.
Yeah. So those with the green.
Mm-hmm.
Okay. So
It,
that's correct. You can just assign that as part of like some assessment
mm-hmm.
online, right?
Mm-hmm.
I mean, I usually like to have kids like go back and see what mistakes they made and all of that. They just can't document that on like on a Google Doc or something like that. Is that right?
Like if it's in their internal Google Doc, something they're not publishing, I think that's fine. Let me double check on that before I say yes, no on that.
Okay.
And so I'm going to go to my lovely little resource here. The Google AP Classroom teacher only. Up on that, teacher only resources. Questions. I saw that as a thing. So certain questions on that thing. And so this is coming from the, let's see, the AP thing. It's off of the, yeah, in classroom use and kept secure, select after use, not for take home assignments or post online. So that would be, yeah, those are the ones that they only on the in class stuff. So not a take home assignment, not a work whenever assignment. Usually has it set for the secure browser by default.
Mm-hmm.
And so, yeah, but so those are the ones like, and so if you miss that question, okay, this can't be, you can't take this and put on your thing, but here's like this is what you got wrong. Here's how you can practice for it, and that so they don't actually put the question or anything in their stuff.
Right.
They can write about the concepts and stuff themselves, but not put the actual question on any printed slash shared externally document.
Yeah. Okay. So I usually have them, I told them don't write the exact question, but maybe paraphrase it or just write a little um, something to remind you.
Like if you see this kind of question, here's how to solve it. Yeah.
Yeah.
Yeah, not the
Okay.
exact question, but the here's how this logic works. Totally. Yeah.
Okay. All
Yep.
right. Thank you.
Yeah, that's a great practice. Yeah, having your students reflect on their wrong answers and especially extract actually it's even better to not copy the exact question, but to generalize that content and then to like go from there. Because that actually makes it even more useful for the student because they've learned how to extract that information. And so yeah, that's totally a great thing. Drive safe. Love you. Okay. My beautiful wife is on her way home from work, so telling her to drive safe. Um, but yeah, that is a great thing. So yeah, Lillian, that's a wonderful strategy to work with your students on. So totally positive support for the generalize and then reflect. Wonderful strategy for being successful. Yeah. Other questions about working with file IO, strings, the Magpie lab, array list and array, those content areas we worked on today, and creating objects. Giant pile of stuff today. Oh, wait, we did a giant pile yesterday too.
Did we cover I mean, I know we covered the strings, but string IO, was that something that you
Yeah, that was the project we did in Eclipse. So if I pull it back up this morning, window, where's my,
a file?
yep, the string file IO. Yep.
Oh, okay.
Yep, that was the one that we did today, and we'll be doing more with that. That's the wrong demo. That's the other Eclipse window. There we are, Augsburg's. Okay, that would be this one right here when we are working with the IO controller to read the string from a file. Yep.
Okay, so in that context, is file IO the same as string IO?
Yeah, the string IO. So it's file
Yeah.
IO with strings. So that's what that note was about.
Okay.
Yep. Yeah, thank you. Yeah, so that one is just how we can actually get content from the file, bring it to a string, and then use it in class somewhere else. Okay, great one. Any other questions, comments about today?
I feel stupid asking this question, but I'm going to ask it anyway. And I
Please.
use Eclipse, so I should know the answer. But when working with the file IO stuff,
Mhm.
let's say I have a file that I want to give to my students. Do I have to share that file with them and have them put it into that source folder, or
In
is
the
there a way to
project
reference
folder.
it from anywhere?
So you can use, if it's on, like, say, for example, if you have a shared network directory system that all has the same file name access, like say H colon H, the H drive or the Z drive or whatever you have for your school, you can use what's called a absolute path for that. And so instead of having the path right where I did right here, if I go to my controller for that file, where I did demo.txt, and that's using a relative path saying, oh, I'm just going to look right now. I'm going to look at my project for that. And it's just right here inside the project level folder for this. And that's just the relative, it's just looking for it right there where I'm at right now. I could specify the actual full-on path to that file if it's a shared path that doesn't require login permissions to access, that they have access to through their operating system.
So, like, if they had internet or whatnot, you could give them like an internet address and they could go to that. Would that work?
Not this way, but yes. So if you
Okay.
want to read from a web address, there's a couple extra steps to make that happen. But yes, you can do that as well. And so
Okay.
WebIO is you have to first create a port access and grab that or use JSoup and retrieve that information off of the internet. So
Okay, so there are ways to do both if I have like a text document and I say, here's a location that everybody can access versus here's a website that you could do and everybody could do it.
yeah, and I have a video on how to get it from web too.
Perfect.
Yeah. And so, but if it's just a file that you just like, so like if I give students a source file, I'll just put it in my Canvas system, they drop it in. And if you just go from Finder window, let me get my Finder window open. Okay, there's a Finder window. Hey, here's the chat log from our meeting today. Meeting saved new chat.txt. I can just drag this right here, regardless of operating system, straight into my project. Cancel out of that. Let's try that again. Let's see. So go back to here. Dupe, dupe. Meeting save new chat. Drag that into, not the text clipping. Derps. Drag that in right here to this. And I want to copy that file right here to the project. Yep, okie dokie. And boom, it puts it right there in that root directory of the project. And I could use that.
Okay, that makes it much easier because I was trying to figure out like for some of it I want to be able to like know if they're doing it right.
Uh-huh.
So I want to have control over what text they're using, but I wasn't sure how to like what the easiest way to do that would be. But that's actually
Yeah,
really
just
really
drag
easy.
it straight in from Finder or Explorer, right in. And if it doesn't work, well, did you drag it in? No. Because if they choose reference, I'm like, oh, no, no, no. I don't want you to try and reference that file. I want you to copy the file right in so it's right there in the project. Because then if
Okay.
they're trying to reference it, like, oh, if they change it or screw it up, which never happens. Yeah.
Yeah, they always do everything perfect the first time through, right?
Yeah, and I'll practice. Here's how you bring a file in. Here's how you bring a file in. How do we do this? Here's how we bring a file in, and do that again.
Okay. Perfect. Thank you.
Yeah, no, that's it. And so I practice that with them a lot. Great question. Any other questions or comments? Okay, exit ticket today is a survey, same as last time, just at the bottom of the document. Um, we are We're doing great, I think. So our end of day survey. We'll be working more with this and more with data tomorrow. So we're going to talk about the Q3 exam, the 2025 Q3, the question on that. We're going to do more file I/O, working with the algorithms that have to happen with array and array list. We have a little async work, working with data structures, and we're going to start working on 2D arrays and all the labs. So a pile of stuff tomorrow, just like today, but a different pile. If you have questions or anything, please feel free to let me know. I will post this video after it renders. Have to make sure I mark you all here too. I have that. I didn't mark it right after class yesterday, so I have to make sure I do it today. Augsburg Canvas attendance sheet. Cameron, you're here. Ray is here. Rati is here. Amina's here. Alexa, you're here. Tara, you're here. Lillian is here. Jess is here. Torin is here. Jamie is here. David is here. And Kai is here. Hooray. Makes life easy to mark roll, especially if I know we have a legal requirement to mark roll. Who has forgotten to mark roll more than once? So I usually do it like, for me, it's like, oh, I do it like within a few minutes of class starting. And it's like, oh, you're not here yet. Remind me to mark you here, or you're absent. Because I'm like, I don't want to go back and mark people tardy. So I just do the roll once. And it's like, if you're tardy, it's like, and so I try and train students to remind me about that so I don't have that cognitive load. Because that's just a chore. And I'm like, I marked you absent already. I can mark you here if I need to. But
Yeah, our district has really gotten into using two-factor authentication, which is obvious important for obvious reasons, but every time I sign in for for attendance, I like have to wait for my code and then something inevitably happens and that code is no longer valid by the time I go take attendance and I'm like, "Oh my God, I completely forgot who was here and who wasn't."
yeah. And then you have to go back and like, okay, there's someone sitting here and
Exactly.
there was this person here. Yes, they
Hmm.
turned something in. Yes, they were here.
Exactly. I'm like, "Oh no, not again."
I'm glad I don't have multi-factor on attendance.
We have to now. We have to with everything.
I It's probably going to happen in the near future, would be my guess.
Hmm.
With my cooperating college that I work with for the concurrent enrollment, everything I log into has a separate multi-factor step. So it's login, multi-factor, login, VPN, login, multi-factor, and VPN.
Hmm.
And it's like click, wait, approve, click, log in, get the code, type in the code from email.
Yeah.
It's like, can't you just give me it? Can I use the other thing? No, you have to get the email code on top of the login, plus the VPN has to be connected too. I'm like,
And I can't use my school Gmail for anything. They don't let us use sign in with Google anymore for really anything.
I don't use my school email account for anything other than intra-district garbage that I don't create.
Right.
It is there for, it's like students, it's like email me on my Gmail account because it always comes through. My district blocks random things. And our district is marked as spam for multiple email providers because, well, some teachers do spam, but
Right. Yeah. Reply versus reply all.
oh gosh. There is a specific teacher at my school that does not understand reply all, should not ever be used. Every message is reply all, every
It's
time.
terrible.
And so it's just like, as soon as it's like that person's email is filtered to the garbage because they don't send anything that I actually need. Because everything they say is a reply all to someone that they really shouldn't have sent in the first place as an email. Like this could be handled with a thumbs up somewhere.
Hmm.
And I don't understand how it's like, why is reply all the default on Outlook? Like why is it there? It should be something you have to choose, not like have a
Right.
default.
Are you sure you want to do this?
Are you really, really sure? Say lovey. Okay, I hope you had fun making your monsters. I really like that project in person. But even drawing silly things is still fun. And creating snacks with mammals is fun. Um, we'll do a lot more with our data structures and stuff. I hope you got some year planning stuff taken care of. I hope you have a fabulous day. Have a great evening. I'm looking forward to seeing you all in the morning. Have a great day.
Thank you. Have a great day, everybody.
Thanks. Cheers,
Thank
peeps.
you. See you all tomorrow.
Yeah,
See ya.
thanks very much.
Thank you.
Appreciated the day.
Thank you.